Good morning, folks. Welcome. As most of you know, my name is Kevin Klein. I am an inspector with the Virginia Department of Environmental Quality, and I will be facilitating this webinar on water quality and watershed implementation plan progress for Delmarva states. I would first like to start by thanking our participants for agreeing to join us today. It is greatly appreciated. I would also like to thank Michelle and Paula, Kristen, Andrew, Kelly, Nancy, and everyone else who participated in pulling this together for DLLC. That is greatly appreciated as well. Viewers, if you don't mind, please take a moment to introduce yourselves in the chat. And just a reminder, we are recording if you would like to view any part of this presentation again in the future. Our goals for today are stated on the agenda that Paula and Michelle provided. But to summarize, we hope to learn more about nutrient trends and surface and groundwater and how agriculture affects those trends. We also hope to explore the impacts from Delmarva when compared to the Bay watershed as a whole, and how agriculture on Delmarva is progressing in regards to TMDL and WIP goals. One note, DLLC focuses on solutions that will reduce impacts to all of Delmarva's waterways. During the webinar, there will be information that has a focus on the Chesapeake Bay watershed, such as the specific WIP and model results, but there will also be other information, such as the USGS data and descriptions of on-the-ground practices that cover all of Delmarva. We've asked the speakers to cover all angles as they are willing and able to do so, while being clear about whether their information covers all of Delmarva's landscape and waterways or focuses specifically on the Chesapeake Bay. We will have some time for discussion at the end, so please feel free to send in questions via the chat. One additional note from me, with this fantastic group of speakers, I would appreciate it if you include a note on which speaker or speakers your question is directed to, so I can make sure to point the question in the correct direction. All right, well, that's enough of me talking. I'd like to get started with our first presenter, Alex Sorka, who is a physical scientist at the USGS, Maryland, Delaware, DC Water Science Center, and will be presenting on Delmarva water quality trends and factors. Alex, welcome.
Thank you very much for the introduction. I'm going to start sharing the screen here. I've got a couple of slides prepared. Screen one and share. Can you all hear me? Yep, I'm getting nods of yes. All right, you can all see yourselves, I'm betting. All right, let's begin. Display settings. There we go. Well, thanks for joining and thanks for inviting me here today. I was asked to give a talk that covers groundwater and water quality trends on the Delmarva Peninsula. And a lot of this will be focused on the Eastern Shore. I'd like to thank my co-authors, Jimmy Weber and John Poon, for their assistance in preparing this presentation. And so a little bit of background about myself, physical scientist at the U.S. Geologic Survey. My background on the Delmarva begins about 8 or 9 years ago. Went to the University of Delaware and worked under Amy Schober, focused on soil health practices and fertilizer application to corn, and was hired on and worked with Judy Denver before moving to the Baltimore office. And today's presentation is going to be primarily focused on the non-tidal stations on the Delmarva Peninsula. So on the right side of this image, we have a satellite photo of the Delmarva with an outline of the Chesapeake Bay contributing side and 4 non-tidal stations that give us insight into conditions for management and water quality on the Delmarva Peninsula. The objectives of this talk is to give us a better understanding of water quality trends in the Eastern Shore and some factors which affect those trends. We'll be covering the foundations of what I mean when I say load and what I mean when I say trend. We're going to look at comparisons between the Eastern Shore and the Chesapeake Bay watershed, and then examine recent and long-term trends in sediment, phosphorus, and nitrogen transport from these watersheds. We'll look at possible management impact and factors which are affecting these trends. So before we begin, these 4 watersheds that we'll be discussing are a part of a 120 plus station network across the entire Chesapeake Bay watershed. From each of these stations, we collect between 15 and 45 samples a year, which accumulate in over 2,400 total water samples a year. Each station has a stream gauge, which tells us how much water flow is moving down the stream. And then we also do the water quality sampling to determine concentrations. Concentration multiplied by flow gives us the amount of nutrient that is moving downstream. For the remainder of this talk, I'm not going to talk about exact loads, but what are called flow normalized loads. Flow normalization is the process that we have developed to let you see through interannual variability in flow and discharge to detect if there's a difference in concentration. We then use and detect differences in loading. We then use these flow normalized loads and a trend detection process to determine whether or not there's a change in the beginning or ending time period and whether or not that change is likely significant. So for these sites, in order for us to calculate a load, we demand a minimum of 5 years of regular data collection. In order for us to determine a load and a trend, whether or not we believe there's a likelihood of loads going up or down, we need a minimum of 10 years. The widespread monitoring network allows us to tell different things about the Chesapeake Bay watershed and develop complex statistical models which relate concentrations and nutrients which we see on the export of the watershed to what is happening within the watershed. Now we'll look at some model output. This is the Sparrow Model, which I'm sure you are, oh, I can hit this hide button. This is the Sparrow Model, which I'm sure you've seen some output from before. And what we can see here, I don't want you to focus on exact numbers from that explanation, but this is total nitrogen. The Eastern Shore has higher per area normalized loading of nitrogen and phosphorus compared to the rest of the Chesapeake Bay watershed. Areas on this map that are in darker blue colors have relatively high nitrogen loading, and it's a similar map when you look at phosphorus. You'll notice that agricultural areas pop out across this landscape because, of course, we have to apply nutrients to meet crop needs. But we also see urban areas, such as Washington, D.C. showing up, as a lot of humans can create a lot of waste handled by waste treatment facilities. On the Delmarva itself and the Eastern Shore, applications are relatively higher than the rest of the Chesapeake Bay watershed. Inputs of nitrogen and phosphorus are greater than the rest of the watershed, and also the amount that is delivered per acre of land is higher than the rest of the watershed. The factors which influence this are high nutrient input to the landscape, but also local transport factors, such as the proximity of the Eastern Shore to the Chesapeake Bay. It's fairly close. It's faster to transport things from the field and into the stream. And for phosphorus, that means sediment transport mostly. It's phosphorus bound to sediment. And for nitrogen, we're talking about groundwater, which supplies about 70% of the nitrogen reaching the tributaries to the Chesapeake Bay from the Eastern Shore. When we talk about the inputs to the Eastern Shore, agriculture is the dominant land use. And so it'll have the highest amount of input. From previous work, we have found that over 90% of the nitrogen and phosphorus inputs to the Eastern Shore are from agricultural landscape, which makes sense as the Delmarva is an agricultural powerhouse. And so how have nitrogen and phosphorus loads changed throughout the Bay watershed? Here's an image of nitrogen. The green triangles pointing down means that concentrations are the loads are decreasing, and orange triangles pointing upward means loads are increasing. What we see is that across the Bay watershed between 2009 and 2018, loads have improved at about 40% of stations and degraded about 40% of stations and show no trend in 1 in 5 stations. We've seen large improvements in agricultural areas in the lower Susquehanna and also the Potomac River Basin. Phosphorus trends are similar to nitrogen, improvement of about 45%, degrading at 30%, and no trend at about 25% of stations. When we look at the subset of the Eastern Shore, there's 5 stations, and I'll address this up front. There's 5 stations technically on the Eastern Shore that are non-tidal. One of them, however, is Northeast Branch, is on the far northern part of the Eastern Shore, and is actually in a Piedmont setting, and not like the coastal plain, which is the rest of the Delmarva. So for the rest of this talk, I will not speak a lot about, I won't speak at all about Northeast Branch, but we'll focus on the coastal plain stations. Of the coastal plain stations, we have one that is improving in total nitrogen load. so that the load is going down. That is the Tuckahoe, whereas we see 3 are degrading. And in phosphorus concentrations, all 4 of the coastal plain stations are also degrading. So what are the 4 stations that we'll be looking at today? Each of those black triangles represents a USGS gauging station. The black line is the relative contributing area. We're talking about Tuckahoe Creek, the Choptank River, both of which are in the greater Choptank Basin, and then Marshy Hope Creek and the Nanticoke River, both of which are in the greater Nanticoke Basin. This highly colored map on the background here is an aquifer thickness map. And it was estimated using the land surface and the confining unit underlying these lands. And so you can see that these 4 different watersheds have a pretty wide difference in the aquifer thickness that's below them. And this has important implications for when water reaches the land surface, trickles through the unsaturated zone, becomes groundwater, and then is transported to streams. So let's look at these 4 stations. First, sediment. I'm mentioning sediment now as it's important for phosphorus transport. Since 1985, we've seen an overall decrease in sediment, but increasing trends since 2009. Between 2009 and 2018, suspended sediment loads have increased by an average of 30% at the 4 stations we were discussing. This is important because sediment is a dominant mechanism that helps phosphorus move through waterways. Phosphorus binds to sediment, and when sediment is mobilized, phosphorus moves with it. So phosphorus figures look similar. The Nanticoke is showing a long-term decline, but the recent trend since 2009 shows an increase at all 4 stations for total phosphorus at an average increase of about 40% of the load since 2009. And orthophosphorus is also increasing at all but the Nanticoke station. The 3 stations have an average increase of 80% load in orthophosphorus since 2009. We'll look at a couple of drivers of phosphorus and how phosphorus loads are changing and why. Phosphorus loads are changed by the input to the landscape and from the transport of that landscape to the stream. The Delmarva has a long and strong history of being an agricultural area, and we've applied high phosphorus fertilizers, so fertilizer and manure, to the landscape for many years. As phosphorus binds to soil, that leads to a buildup of phosphorus in soil, which unfortunately may not be available to the plant, but can still be mobilized in water. And so high soil test phosphorus can be an additional issue in agricultural areas. As an example here, I have a figure taken from the University of Delaware soil test facility. And this is from 5,600 agricultural field soils that they sampled between 2007 and 2011. 62% of those were considered excessive by the Delaware Soil Phosphorus Site Index. I'll now show you some results of water concentrations. So this is concentrations of suspended sediment, phosphorus, and nitrogen. And these are displayed against flow on the x-axis. The further you go to the right, the more flow that you see the more flow you see coming out of your rivers. And red and blue are phosphorus and sediment. So you can see that as phosphorus and sediment increase with flow, nitrogen decreases. Phosphorus and sediment are mobilized by the kinetics of water. Powerful water, moving soil, moves phosphorus as well. Nitrogen is getting diluted as it is from primarily groundwater sources. Continued applications of phosphorus and load them to the soil provide phosphorus saturation within the soil itself. Rosemary Finelli, Joel Blomquist, and Dr. Rob Hirsch, Finelli is also a PhD. They recently published a paper that examined 53 watersheds in the Chesapeake Bay that had 9 or more years of consistent orthophosphorus data. And what they found was that orthophosphorus concentrations were strongly linked to manure applications of phosphorus, but also conservation tillage. And so in this image here from the Choptank River near Greensboro, Maryland, we'll see 2 different plots. Well, we see 2 different lines. They're both over discharge. So as discharge is increasing, we see an increase in orthophosphorus, the dissolved form of phosphorus. And between 95 and 2005 and 2006 and 2014, there was a change such that concentrations are increasing across all levels of flow in the more recent time period. Applications provide a challenge. We have other speakers here today. We'll get more in depth about nitrogen and fertilizer applications. but I wanted to show you a map that my colleague Jimmy Weber put together, showing cast input data describing a long-term decrease in phosphorus applications across the eastern shore, mostly. But recently, since 2009 to 2019, we're actually seeing an increase in Delaware counties and select Maryland counties. Maryland coastal counties are all showing a decline in phosphorus application. This will provide future challenges to land management, as continued input can lead to continued export. We'll take a look at nitrogen now. Nitrogen loads have been increasing in most of the monitored trend sites on the Delmarva. The Choptank, Marshy Hope, and Nanticoke are all increasing in terms of nitrogen. And Tuckahoe is not. Tuckahoe is going down by about 2.5%. But what I'd like you to notice about this figure, as said earlier, nitrate is an important part of nitrogen transport. 70% of the nitrogen reaching the streams on the eastern shore is delivered by groundwater, and that's nitrate. And so you'll see out of the total pool of nitrogen, nitrate is the dominant species. What's interesting here, the Tuckahoe is decreasing. We'll get into that in a second. The landscape can control nitrogen transport and also foster denitrification. We're back to the Aquifer Thickness Map, as this helps describe some of the processes which groundwater goes under throughout the landscape, as the landscape is heterogeneous. In much of the superficial aquifer, nitrate remains relatively stable because of oxygen-rich conditions. When there is no oxygen in the water, bacteria will choose other forms of nutrients and move towards nitrogen and undergo a process called denitrification. In the Choptank River watershed, here's an example of groundwater flow paths. So those green areas are meant to represent areas of low oxygen and higher denitrification rates. And those orange areas are meant to represent oxygen-rich areas where nitrate remains conservative and it stays within the water. In the Choptank, loads are generally lower, and that is likely due to hydric soils, low permeability, a shallow groundwater table, which promotes anoxic conditions and so denitrification. If we look at the Nanticoke River, you have a relatively thick superficial aquifer. And so with that thick superficial aquifer, you have more opportunity to circumvent those denitrification zones and have input directly into the stream. And the Tuckahoe here is somewhere in between the Choptank and the Nanticoke in terms of the superficial aquifer thickness and groundwater residence time. So the Tuckahoe is decreasing in total nitrogen export, and these loads differ in between the growing season. So I'm talking about the corn growing season, so generally, beginning of May into September, and the non-growing season. So when we split out the change in flux of nitrogen in the Tuckahoe watershed between growing season, that's this green line, and the non-growing season, the brown line, we see large gains in the non-growing season, whereas there's large gains in the non-growing season, which offset the small increases in nitrogen during the growing season. What could be impacting this? We recently published a paper looking at one of the conservation practices in the Tuckahoe watershed. So we're looking at cover crops. This image here is from a Landsat satellite, and what we were doing was measuring the greenness on the surface of the earth during wintertime. And we can relate that back to the biomass held by these cover crops and relate that to nutrient content on average. That, coupled with modeling, suggested that we were reducing up to 25% of the nitrogen leaching from the fields during wintertime. And so conservation practices such as this may be having an impact in the Tuckahoe. And the Tuckahoe is also seeing, if you look at the cast maps that I'll show in a second, the Tuckahoe also may be showing a decrease in the amount of nutrients that are applied to it, the amount of nitrogen applied. These results are supported in an excellent paper released by Fox and others, Rebecca Fox and others from Horn Point. They had, I believe it was 12 or 13 different sub-watersheds that they've been monitoring in the Tuckahoe watershed, shown here on the bottom right. And what they found is that in about half of those watersheds, they're showing decreases in base flow nitrogen, so the contribution of groundwater we're showing decreases in nitrogen, which is a great story. Now, one of the questions with nitrogen is, how long will it be until we see an impact from our management decisions? Groundwater nitrogen is comprised of multiple years of different flow paths. Some flow paths can move on the order of a day when you have a storm. Some flow paths take a year. Some flow paths take about 50 years. And this model here, developed by Sanford and Pope in 2012, gives us estimates of the age of groundwater. And so the land management practices which we apply may take time to see impacts of. Fox and others, 2021, once again, in the sub-watersheds that showed improvement, suggested that the improvement might take 53 years for those streams to have no net impact on the Chesapeake Bay. Whereas Pope and Sanford in 2012 estimated that a 40% reduction would bring us down to the nutrient goal in about 30 years of time. And so groundwater provides a challenge to management as our past uses of nutrient and past landscape are still turning up today. So once again, here's a map of cast input data, which I'm sure will be described later in this webinar. Cast input data describe increases in nitrogen applications on the Delmarva since 1985, and in some counties after 2009, but not all. This will provide future challenges to nitrogen management. Okay, so this is the last technical slide, and I'm going to talk a little bit about a groundwater monitoring network in the state of Delaware. This was put together by the partnership between the Delaware Department of Agriculture, Delaware's State Geologic Organization, and we've been doing the sampling for it. It's a network of 48 wells. In the shallow part, there's 48 shallow wells in the superficial aquifer. The point of having these shallow wells is that they should be your first indication of changes based on land management practices. In the first sampling of 2014, these wells were split into between 3 different groups. While they're all majority agriculture surrounding the well, some of the wells had a higher agricultural signature in their water than others. So urban type waters, high in potassium, high in sodium. Agricultural type wells, high calcium, high magnesium, high nitrate. So we split these into 3 groups, 1 being agriculture, 2 is a mixed type water, and 3 is an urban type signal. Between 2014 and 2019, we did not see a significant change in the nitrate concentrations in any of the 3 groups, indicating that we didn't find a change in between 2014 and 2019 in terms of nitrate concentration. So to sum up this presentation, I understand it was a lot to swallow here, but despite long-term declines, stations are showing an increase in sediment and phosphorus loads from 2009 to 2018. Nitrogen loads are increasing in all stations except for the Tuckahoe, and management strategies are challenged by the past, current, and future inputs, as well as the landscape. Concentrations of nitrate in the Delaware superficial aquifer suggest that we may be maintaining our nitrogen loading rates into the future. And with that, that's the end of the presentation. I'll take any questions.
Thank you, Alex. Thanks a lot. That was a lot of great information, and we appreciate it. We will have, just a reminder, we will have some time for some questions at the end. So please send those over as you see fit. But for now, I'd like to thank Alex one more time and turn it over to Lindsay Thompson, noted DLLC member and executive director of the Maryland Grain Producers Association and chair of the Delaware Maryland 4R Alliance. She will be presenting on 2 topics, trends in agricultural production, and I'm going to just shorten this to the big program modeling process. Lindsay, good morning.
Good morning, Kevin. Let me just put my video on here. And just to clarify, I'm going to talk about the trends in ag production and then take a break and then move into the Chesapeake Bay program portion, or just do it all at one time.
You can go ahead and do them both in a row. If you want to pause for any questions that we have a little bit extra time, you're welcome to do that.
Okay, great. Sounds good. So good morning, everyone. My name is Lindsay Thompson, and I am the Executive Director of the Maryland Grain Producers Association. I also work with the Delaware Maryland Agribusiness Association, and that is where my hat as the chair of the Delaware Maryland 4R Alliance comes into play. And so I am going to talk about trends in agricultural production on the Delmarva. But I thought that to start, a very telling slide here, and this is from the U.S. Department of Agriculture, just looking at corn yields across the entire U.S. And we'll dig down a little bit deeper into Maryland and Delaware, and specifically the Delmarva here in a moment. But you can see all the way back to 1860, looking at fairly flat yields up until about the 1940s on corn. So we're looking at somewhere in the 20 to 30 bushels per acre range. And then you see the increase here starting in the 1940s and working its way up. And I'm also going to talk a little bit about agricultural technology, but one thing to note here is the advent of genetic modification, or GMOs. And so on the Delmarva, we see approximately 90% of the corn and soybeans planted on Delmarva are GMO crops. And so this kind of straight line up here with a little bit of a dip, and we'll also talk about this, 2012 was a tough year for everybody with some weather issues. But once we had GMOs here, we saw kind of the straight line up, and we're seeing averages in the 170 to 180 range nationwide, which is also true of the Delmarva as well. So moving here to our next slide, I just did the total acreage of crops on Delmarva. This is USDA census data in 2012 and 2017. And then I included annual mass survey data from 2019 and 2020. You see a little asterisk here. There was some omitted data in Delaware, specifically in Kent County, Delaware, in the 2017 census. So overall, you'll see here in Maryland, back in 2012, we were at about 625,000 acres of corn, wheat, and soybeans harvested. And I say harvested because we'll also talk about the high level of cover crop implementation. So while there's a lot of wheat planted in both Maryland and Delaware, there's also a lot of wheat that is not fertilized and harvested. And so if you kind of look at this trend, even omitting some of the data in 2017, we're seeing a gradual decline in the overall harvested crop acres on the Delmarva. And a lot of that is due to land use change, development pressure, and taking land out of production for set-aside acres as well. So focusing here on Maryland row crop yields, we have here in the bright green is corn. The darker green here is soybeans, and then the more teal color is our wheat. And as you can see, there is an upward trend in the corn yield. Again, 2012, it just didn't rain for an entire year. So we had a tough year on corn in 2012, but even not considering that, 2013 to 2017, we are looking at an increase. And the 2020 numbers, I believe, for Maryland statewide, were at about 178 bushels So we're continuing to push that average yield. And I will say, as a caveat, I talked to a lot of farmers. I'm the director of the Grain Producers Association. So in checking on my farmers throughout the state this year, I would say we are probably going to be about average overall, but there are farmers in some localized areas, specifically in the Chop Tank watershed and down on the lower shore, that cut the best corn that they've ever had. They just had perfectly timed rain, so most of them were averaging up over 200 bushels, which is exceptional given their yield potential and their soil types there as well. So overall, we're seeing a slightly downward trend in harvested crop acres and an upward trend in the yield on those acres. I'd like to talk a little bit here about nutrient management and the 4 R's. So for those of you that don't know what the 4 R's of nutrient stewardship are, it's the right source of nutrients at the right rate, at the right time, in the right place, right? And so this can be applied to both synthetic or commercial fertilizers as well as manure. And both Maryland and Delaware have regulatory nutrient management programs. And so I'm going to say in most cases, your limitation is 1 pound of nitrogen per expected bushel yield of corn. There are some caveats to that. If you can demonstrate a deficiency with a pre-side dress nitrate test or tissue testing. And now the Chesapeake Bay model includes the 4 R's as the basis for nutrient management enhancements. So we have core nutrient management in the Chesapeake Bay model, and then you can do rate, timing, and placement enhancements for additional credit on nutrient management acres. We talked a little bit about GMOs, but I will say that in general, technology is rapidly evolving in agriculture, right? So we are always looking for seed advancements, nutrient enhancements, so things like nitrogen inhibitors, slow release nitrogen treatments, different application methods. So the 4R Alliance had a field day over the summer, and Willard Agri-Service demonstrated all of the different application methods that they could do with their sprayers. And it's really cool, putting those nutrients right where the crops need them and when the crops need them. And then we're also seeing a rise in biostimulants. And the regulation of biostimulants is not quite figured out within the states yet, but there are things that, for example, there's a company called Pivot Bio that's using a biostimulant that actually allows corn to fix nitrogen, similarly to soybeans. So I think that we'll see some changes in the application of nutrients due to biostimulants as well. Nutrient use efficiency. And so you heard Alex talking about the increase in nitrogen application on Delmarva, right? And so what I would like to kind of point out with that is in order to grow more corn, you need more nitrogen, right? And so as we're seeing those increases in application, we're also seeing increases in yield of corn. And in general, corn is about 70% effective in its nitrogen use efficiency. So you also heard Alex say, for about every 70 pounds of nitrogen applied per acre on the Delmarva, we're seeing in about 11 pounds per acre delivery. And so, as a farmer, you're saying, okay, well, I'm there about looking at the nutrient use efficiency as well. And the other thing that farmers have to factor in, obviously, is weather variability, right? And the 4 R's are really helping farmers to avoid the loss of nutrients due to weather variability based on timing of application. Jen Nelson, who's on the call today as well, I remember shared a picture on Facebook a couple years back, and it was a cornfield where the corn was, you know, about knee high and about halfway covered up in water. And it said, you can't lose nitrogen you haven't applied, right? So the 4 R's are encouraging farmers to not apply all of their nitrogen up front, you know, pre-plant or at planting, but waiting for those later application dates at side dress in order to avoid losing that nitrogen either due to drought, where the plant is not growing in a way that it can effectively take up that nitrogen, or water, where we could, you know, potentially lose that nitrogen to surface flow. All right. And Alex touched on a little bit of this as well, but Maryland and Delaware have a high level of cover crop implementation. And so Maryland actually nationwide has the highest proportion of cropped acres in cover crop over the winter, and Delaware is working really hard with their cost share programs, both Delaware Department of Agriculture and the Soil Conservation Districts, to get cost share out there to get those cover crops on the ground. We're also seeing a rise in subsurface and agricultural drainage practices. So your bioreactors, your agri-drains, your gypsum curtains, you know, things to hopefully start to try to address some of those subsurface flows of nutrients. Maryland has increased their cost share rate to 100% on some of those long-term fixed natural filter practices, such as your grassed waterways, your riparian and grassed buffers. So I think that that will continue to help with implementation. And one thing that I did want to point out is that cost is going to continue to be a factor moving forward for BMP implementation. And I think that cover crops is a good example of that. We are seeing increased input costs in agriculture, just as any industry is right now. But seed and nutrients and crop protection chemicals, equipment, and diesel, you know, the cost of all of these things is going up, and therefore the cost to the farmers to implement these BMPs is going to go up as well. All right, so I'm going to jump right into the Chesapeake Bay program partnership side of things and talk a little bit about the structure and my involvement in the past in the agriculture work group, as well as the water quality goal implementation team. And so the Chesapeake Bay Program Partnership is a broad partnership of state and federal agencies, soil conservation districts, universities, you know, farmers, environmental NGOs, agricultural organizations. And so my primary involvement in the Chesapeake Bay program has been on the agriculture work group. And in order for a best management practice to be included in the model, it has to go through an expert panel process, right? And so expert panels look at all of the available data and put together a report and to determine the efficiency of a best management practice in reducing nitrogen, phosphorus, and sediment. And then that goes through an approval process at the agriculture work group up to the water quality goal implementation team. And sometimes, if necessary, things have to go beyond that to the management board as well. As far as the input go. A lot of things in the past have been done at the Ag Modeling Subcommittee, looking at crop acres and land use, nutrient input. And so I'd like to focus on two things that I was either involved in or on the Ag Work Group when they were going on. And one was the Poultry Litter Subcommittee. And so probably especially interesting to DLLC. The Poultry Litter Subcommittee was put together back in 2017, I believe, when the new Ag Census data came out. And the number of broilers on Delmarva, or really kind of Bay-wide, didn't match up with the projections that had been put together after the 2012 census. And so the Poultry Litter Subcommittee got together and put together a new method for estimating the number of broiler chickens and layers, as well as the litter that they produced. And that was a partnership effort. It got a little bit controversial at times, but ultimately I feel like it was a good outcome. So that's one way that the partnership worked together to address what was seen as, an inaccuracy in an input in the model. The other thing I wanted to talk about was the Appscode data. So Appscode is the American Association of Plant Food Control Officers. And there is a plant food control officer in each state that gets the information on nutrient tonnage being sold in that state. So myself and a gentleman by the name of Bill Angstadt, which many of you know, who had been involved in the Chesapeake Bay program for a long time, from the agribusiness side of things, got together and looked at kind of the total nutrients that were being estimated to be applied in the model, and then looking at the Appscode data and identified a discrepancy in nutrients, commercial nutrients, not manure, commercial nutrients being applied and nutrients that had actually been sold, right? And the model was estimating a higher level of nutrients being applied than nutrients that had ever been sold. And so we came up with a method to, aggregate that Appscode data and then disseminating that down to spreading it out throughout each of the counties based on their nutrient management acres and their crop acres. And that resulted in, a reduction of modeled nutrients being applied in the model. And so, I think that the Chesapeake Bay Program Partnership is a good example of a partnership, right? Most of it operates through consensus. Things get controversial at times. Nobody's ever going to agree on everything, but it's important to have all sides of the story represented, from the state and federal agencies to the conservation organizations and the agriculture groups, so that we can all kind of look at the big picture and meet somewhere in the middle. And this is one of my favorite quotes. So all models are wrong. They're models, but some are useful. And that's George E.P. Box, who had said that. And so, we're not expecting any model to be completely accurate, but we can all kind of work together to make it as accurate and useful as possible. So just to kind of synthesize everything that I've covered so far, as far as trends in agriculture on the Delmarva, we are seeing a slight decline in cropped acres. Some of that may actually have been due to wheat quality and wheat pricing. And so we may this year see a little bit of a bump in harvested wheat acres. And so it's a trade-off every year based on conditions as well as price. We are seeing over time a continual upward trend in yields in both corn, soybeans, and it had been pretty flat in wheat. And with that increased yield comes increased yield goals and therefore nutrient application. But agriculture is overall doing a lot of things to increase the nutrient uptake, the nutrient use efficiency, and applying nutrients when the crops can most effectively use them through the 4 R's. And then as far as the Chesapeake Bay program partnership goes, I would say that, again, a plug for involvement. It's important to have everybody involved in the process and continue to improve the model inputs to make the outputs more accurate. And that's all I have. Thank you.
Lindsay, thank you very much. That quote at the end was great. I think it's easy to lose sight of the fact that this model we're always talking about is exactly a model. Sometimes it seems like more than that, like a living being that we have to try and keep happy somehow. So anyways, thank you, Lindsay. We are a bit ahead of schedule. So before we move on to Jeff, I am going to bring it back to a couple of questions we had for Alex. Alex, if you don't mind. Chris Basin asks, was there a difference in the proportion of ag lands with cover crops among the Tuckahoe and other watersheds reported on that could be could be influencing the difference in loading? So can we talk a little bit about that?
Absolutely. That's a great question. And we currently provide assistance to both the states of Maryland and Delaware in understanding cover crop performance. And we do this by using satellites which image the entire Delmarva. And what we do is it's called remote sensing. The sunlight hits the plant and we measure the different wavelengths that are coming off of the plant. And we've developed relationships from samples that we've connected on the floor to the biomass within the plant. And so when we do this imaging, I'm going to share my screen once more. And I've got a couple of pictures of, I was trying to figure out what color scheme to use because the acronym is NDVI, Normalized Difference Vegetative Index, but it doesn't make a whole lot of sense to the human eye. So let me share the screen for a second. Is it sharing? All right, great. So this is a piece of mapping software that we're looking at. Here's the Delmarva Peninsula. And this is normalized difference vegetative index. So the higher values here are blue. Blue would be like a dairy farm's extremely luscious fields. And then red here are fields that are relatively barren, are left fallow. And so if we take a look at the data being displayed, this is the winter of 2018. And if we look at the data being displayed, the Tuckahoe, all right, so for 2018 actually has a little bit more red areas than the Choptank watershed. This is not only agricultural land. I couldn't find the only agricultural land data set, but the implementation between these four sub-watersheds is actually relatively similar. You see some really excellent performance down here in Delaware. Look at that. There's some really nutrient-rich fields. That looks fantastic. And on a year-to-year basis, so let's say we'll take away the 2018, we'll apply the 2019-2020 winter layer. We see fairly similar trends in all four of the stations. Maybe a little bit less in the Nanticoke and the Marshy Hope. But also these trends can change from year to year, depending on some local weather patterns. From what I looked at, I don't believe that there is a huge difference in cover crop implementation between these basins. Oh, and also there was another question from Jen Nelson who asked, why is there an increase in sediment in the non-tidal monitoring stations? So the question of sediment in the non-tidal monitoring stations, in the research community, it hasn't been given the most attention. They're focused on the areas with the highest loading. So on the eastern shore, there's two different places the sediment's coming from. It's either field erosion or stream bank erosion. And the last figures that I saw had a relatively even distribution between stream bank and field erosion. And there's going to be, and we have continued analysis on this with the factors team and other teams. And we will hopefully have more information on that, why sediment is increasing.
Alex, thank you.
Yeah.
Great answers, much appreciated. We do still have another couple of minutes. We're still a little bit ahead. I know Michelle asked a question in the chat about take-home messages, and you put an answer in the chat, but if you wouldn't mind expanding on that for just a minute or two here, that would be great.
Yeah. So yeah, sure. The take-home messages of the Delmarva are that we are seeing changes in the Tuckahoe in terms of total nitrogen. Total nitrogen looks like it is decreasing in the Tuckahoe, and that is reported again in sub-watersheds that have been monitored by the Tom Fisher and Rebecca Murphy group. And I think that is a positive story, but it's also with a little bit of caution that the changes that they are seeing, they estimated that it would take about 50 years, plus or minus 11 years, for us to get to a net zero impact on Chesapeake Bay nutrient loads. Now, phosphorus is connected to sediment, and sediment loads are slightly increasing. So phosphorus loads are slightly increasing, and continued application of phosphorus. So it's quite a problem, right? Everyone on this call who's an ag service provider or who works in farming knows that if you stop applying manure, you may have issues with your yield. But at the same time, continued application of fertilizer and phosphorus may increase soil phosphorus levels, allowing for more transport. We've related phosphorus transport into the waterway to phosphorus applications. So as phosphorus applications continue to increase, it may be a challenge for water quality management in the future. Other than that, I thought there were some great comments in there from Lindsay about nutrient use efficiency and movement. And I don't have any more to expand on the take-homes, but I will show you an interesting figure that I have. So Delaware's land-grant university has been keeping records of corn yield since 1865. And so here's a figure that, which is kind of neat. So if you look from 1865 until now, this is your corn yield. So you see that takeoff in 1950. It's a combination of the green revolution. You've got, right after World War II, we took all of our munitions plants and figured out you can use that nitrogen fixing technology. Instead of making explosives, ammonium nitrate, you can actually make fertilizer with it. And so we've got an increase in yield applications. We got an increase in tractor sizes. Tractor sizes have actually gone up between 400 and 500 pounds a year for a new tractor since the year 1950. And so you've got all these changes in technology, all these changes in what we're able to do. And it's really driving what we see on the landscape. And it's incredible also if you check out the yield variability, which we experience. I don't know, this is slightly different. This is a different presentation. But if you look at the yield variability, which we experience, is quite large. This is something that's well known. But if you look at the broiler production, has remained relatively constant. The corn consumption of our broilers has increased over time, but the Delmarva's corn actually shows significant variability due to weather patterns, which is part of the reason why the Delmarva actually has some of the highest rates of irrigation of the entire Chesapeake Bay watershed. Besides the fact that our soils might not have a large capacity to retain water, our soils don't have a huge capacity to retain water, unlike Pennsylvania. So that's one of the reasons that we have greater irrigation. But also, while I'm still talking, I still have the floor. Let me open up. Oh, it's not going to do it because I've got the, my computer's not strong enough to show you a new map. I was going to show you the, we have a map of all the irrigation systems, and you can see that in the deeper portions of the aquifer, you have much more irrigation systems than in the shallow portions of the aquifer. And so your water availability is also an impact there. I could keep talking forever.
Alex, thank you.
I was gonna
Go ahead,
I was
Lindsay.
going to tie in just a bit there. So tying back to yield variability and the capacity of the model, you know, I'll use our own farm as an example. So we had one field this year that actually averaged 260 bushels of corn, right? And it's because I sat on my front porch and I saw some storms that like came that direction and only hit that field and then dissipated, right? Whereas the rest of our farm had a relative drought. You know, we only had 4 inches of rain from the end of April until the middle of August, none of that being between July and the first week of August, which is when you need rain for corn, right? So we saw vast variability in the yields, you know, just on one farm, right? And so when we're looking in the model to kind of apply an average corn yield over the entire, you know, Delmarva or a county or whatever scale, you know, that's one of the things that is a limit to the model is, you know, the specificity that you can really get down to, which impacts overall nutrient application and ultimately nutrient delivery, depending on that nutrient use efficiency of those crops.
Excellent. Lindsay and Alex, both thank you very much for those additional points. Great info. And we take some data and some real life experience and combine them and kind of come to the same conclusion. So that is great.
Kevin, can I say something really
course.
quick before we continue? So I'm part of a group which is working towards getting a better understanding of helpful science and ways that we can meet stakeholder needs. And so we actually have a questionnaire about what people find important in terms of water quality load information and how it's displayed and how you best learn from it. I'd like to drop a questionnaire in chat if anyone would like to respond to it at any time, if you don't mind. Yeah,
that sounds great. Thank you. Thank you. Yeah, go ahead and drop that in the chat and folks take a look at that. And like I said, this presentation will be archived. So y'all can go back and take a look at that after if you'd like. Well, Lindsay and Alex, thanks again. I'm sure we'll have a few more questions for both of y'all as we roll through this. But for now, I will turn it over to Jeff Sweeney with the EPA Chesapeake Bay program presenting on model estimates of Delmarva nutrient loads. Take it away, Jeff.
Thanks, Kevin. Can you hear me?
Hear you loud and clear. Thank you.
Can you see my slides?
Yes.
Great. Thank you. I want to thank the organizers of this for inviting me here. A little background, I've been with the Bay Program Office in Annapolis, Maryland since 1998, mostly with University of Maryland Extension. And then about a decade ago, I jumped over to EPA. I work primarily with the modeling team at the Bay Program Office, but I do a lot of work related to the Chesapeake Bay TMDL, do a lot of work with state agencies in the development of their WIPs and in measuring progress annually on where we are with respect to our goals. Our goals here meaning mostly our goals for reduced loads of nitrogen, phosphorus, and sediment. The idea here is that we do have targets to meet by 2025. In order to meet water quality standards. Eventually, if we hit this certain cap by 2025, we would meet water quality standards. Our primary concerns are dissolved oxygen in the main stem of the bay, chlorophyll A concentrations, and then clarity as a substitute for that SAV coverage. I got a bunch of questions from the organizers here. They were really good questions, and I will do my best to answer these questions in this presentation here as clearly as I can. The first one, what is the Delmarva contribution to the Bay relative to all other regions in the Bay? And then a sub question, what is the Delmarva agricultural contribution to the Bay relative to other agriculture in the Bay watershed. Most of the information I'm going to show to you today is addressing just the Chesapeake Bay watershed portion of Delmarva. So that would be everything to the west of this line here. We do have information for full counties in Delaware, Maryland, and Virginia. We just don't have enough information data really, and a lot of it has to do with the outputs, the monitoring information. So our model is primarily focused on hydrologically within the Chesapeake Bay watershed. So most of the information I'm going to show to you today would deal with the outputs of the model, the loads of nitrogen, phosphorus, sediment for this portion of Delmarva that flows to the Chesapeake Bay. These histograms here show Delmarva's contribution of nitrogen loads to the Chesapeake Bay, to the estuary itself. So this is how much nitrogen is delivered to the bay from the entire watershed, with divisions by each of the major tributaries. So here are the major tributaries here. Delmarva is circled here in blue at the bottom. The other major tributaries, of course, being the Susquehanna, is here, Western Shore, Potomac, and then smaller ones, Patuxent, Rappahannock, York, and the James River. So this is the contribution as estimated by the model from Delmarva for all sources as a whole. So this includes agricultural, wastewater, atmospheric deposition, septic, all the sources for this for the entire watershed. So Delmarva.
Hey, Jeff.
Uh-huh.
There are a couple of questions about whether or not you can put this in presentation mode, just to make it a little easier. Sorry, hate to interrupt your flow.
Is that better?
No.
How about that?
Yeah, that's great. Thank you.
Okay. The time periods here represent, this is a 24-year period from 1985 to 2009. So this is 24-year period here. Our measurements begin in 1985. Of course, farmers have been stewards of the land for a lot longer than that, but you'll often see 1985 as the starting point. This was the formation of the Chesapeake Bay program, and a lot of the data that we use in the model just goes back to here. For example, we go back to the 82 agricultural census is really the starting point for a lot of the inputs to the model that we have, and then we update it every 5 years. The period here, 2009 to 2020, 2009 is kind of the starting point for the formal Chesapeake Bay TMDL. So that's why I've identified that year. So there's 11 years here between 2009, 2020. 2020 represents our current conditions. So these are the model's estimates of loads to the bay of nitrogen currently. And then these are the goals that we have. The 2025 WIP. So if you take all the scenarios that the states develop of how they're going to meet these planning targets here in 2025, you can see that this is the scenario results of the combined WIPs from Maryland, Virginia, and Delaware for Delmarva. Right here is this blue bar. So you can see how things change through time. I'm kind of in a considerable drop here from 85 to 2009. Surely improvements from 2009 to 2020, but we still have quite a ways to go for the watershed as a whole in the next 5 years. This is the same information, but now we're looking at phosphorus. So these are loads of phosphorus delivered to the bay as estimated by the model. You can see a considerable drop here, greater than the rate for nitrogen from 85 to 2009. Again, improvements here out to 2020, but we do have a ways to go yet as well for phosphorus, looking at each of the major tributaries, and Delmarva here being this blue on the bottom, again, that circles. So for nitrogen, Delmarva contributes about 11% of the nitrogen loads to the bay compared to the rest of the watershed. And for phosphorus, Delmarva contributes about 11% as well for phosphorus of loads to the bay. So it is a player, but not as big as other tributaries, such as the Susquehanna, the Potomac. All right, now I'm drilling down just in agriculture. So the question here is, how much does Delmarva agriculture contribute to nutrient loads to the Chesapeake Bay compared to all other agriculture in the Chesapeake Bay watershed. Again, the blue represents Delmarva and the estimates of the model over this 35-year period from here to here, and these are our goals. So for nitrogen, we've made, again, significant reductions over this 35-year period here, but we still have a ways to go to meet our goals in 2025, according to the state implementation plans. So for agriculture, Delmarva portion of the Chesapeake Bay watershed is 16% of all the agricultural nitrogen loads to the bay. And for phosphorus, Delmarva represents about 13% of the agricultural phosphorus loads to the bay. The next question, what level of effort is needed to meet water quality standards in the bay? Over the past 35 years, nitrogen loads to the bay have been reduced 90 million pounds. As a reference point, we're probably currently at about 250 million pounds of nitrogen loads to the bay. So since 1985, we have reduced about 90 million pounds. This is for all sectors, not specifically agriculture. Over the past 35 years, about 61% of the load reductions have come from wastewater controls, while 36% has come from the agricultural sector. And then the next question, what level of effort is needed to meet water quality standards in the Chesapeake Bay? So from here, in our future, if you look at a composite of the WIPs from all 7 jurisdictions over the next 5 years, practices need to be in place to reduce nitrogen loads an additional 43 million pounds to meet water quality standards, according to the model estimates. Over the next 5 years, 88% of the nitrogen load reductions are planned to come from the agricultural sector. So the level of effort that's needed in the future over the next 5 years is 3 times the historic rate of implementation. So I want to cover that. Excuse me, I want to cover that again. So in 35 years, we got 90 million pounds. In the next 5 years, we're going to need another 43 million pounds. And that's why you can see this level of effort is considerable in our future, according to the state implementation plans. And there's also a shift. Many say that it was logical to get most of the reductions in our history from wastewater controls. You can spread out the cost to all users, everyone who pays sewer rates. So it was considerably easier to fund than trying to fund the agricultural community, which is a totally different setup. So 60% of the reductions in our history for nitrogen to the bay came from wastewater, but according to the state WIPs, 88% of our future is expected, load reductions is expected to come from the agricultural sector. Same questions, but now I'm just looking at Delmarva here, the Chesapeake Bay portion of Delmarva. Over the past 35 years, the nitrogen loads to Chesapeake Bay from Delmarva have been reduced 6.5 million pounds, according to the model estimates. 83% of the reductions on Delmarva have come from the ag sector, which is logical. I think the model is currently estimating about 70% of the load from Delmarva to the bay. The nitrogen load to the bay is from agriculture. Alex had a slightly higher figure than that from the monitoring data, but I'm unsure if the monitoring data include wastewater and septic estimates as well. So 83% of the reductions in our history have come from Delmarva, have come from agriculture, and 13% have come from wastewater controls on the eastern shore. And the future for Delmarva, according to the state implementation plan, a composite of Virginia, Maryland, and Delaware plans here, they're looking for another additional 5 million pounds to come from Delmarva. Primarily, of course, 94% of that reduction is planned to come from the agricultural sector, and the level of effort needed in the future is 6 times the historic rate of implementation for the Delmarva Chesapeake Bay watershed. So we have accomplished a lot, and there's a lot more to do. To put those graphically, just those same figures, because I really do want to try to answer this question as clearly as I can. Some people prefer to see numbers, tables, and graphs. Other people prefer words. So here's that same series, time periods here. So here is from 1985 to 2020, this 35-year record that we have. For the watershed as a whole, we've seen 31 million pound reduction in nitrogen loads to the bay. And so this is the area outside Delmarva. Delmarva, you can see the relative contribution of nitrogen loads. This is all sources combined. We've seen 6.4 million pound reduction over this 35-year period. So the reduction has been about the same. So the level of effort in Delmarva over the past 35 years, a 25% reduction of nitrogen loads, about the same level of effort as the watershed as a whole. And then our future for the watershed as outside of Delmarva, we've seen the plans, according to the state implementation plans, we should see another 31 million pounds over the next 5 years. Excuse me. And then for the Delmarva plans as a composite, we're expecting another 5.5 million pound reduction of nitrogen, a 28% reduction in order to hit the planning targets for Delmarva, Chesapeake Bay watershed. The level of effort plan for the agriculture sector is unprecedented. We should not be counting on silver bullets. We've been in this for decades. It's a very complicated system. So therefore, the answers are very complicated. In order to achieve our goals, and of greatest importance are farming methods that achieve ecosystem restoration and sustain our economies. This is logical. According to the state's implementation plans, BMPs are being directed at regions that have more effect on improving water quality conditions, not just for the estuary, but for local water bodies. Alex had a very similar graph to this. This is a little bit of a twist on that. Alex's graph was showing the yields or the loads to local water bodies and how many pounds of nitrogen per acre. This graph here is showing what is the loads to the bay, not just to local waters, to the loads to the bay of nitrogen. From the various regions and the watershed. You can see highlights here along the Susquehanna, South Central Pennsylvania. So this would be Lancaster, Franklin, Adams counties here. The Eastern Shore stands out for these loading rates as well. But in this graph here, it's different than what Alex was showing. He was highlighting Shenandoah region here because his graph was showing the loads to the local water bodies, where this one here is really focused on loads from various regions and how those loads are delivered to the bay, not just to local waters. So this is an area that we're focused on, and the WIPs demonstrate that as well, that this is where we need our implementation in the future in order to get the biggest bang, and particularly the biggest bang for our buck. So you see in the WIPs a lot of emphasis on these regions right here for controlling nitrogen and for controlling phosphorus. In general, recent research emphasizes the utility of input reductions over attempts to manage nutrient fate and transport at limiting nutrient at limiting the nutrients in surface waters. This is a quote from a USGS publication, and I found this rather interesting, and it is very applicable to the shore as well. You don't have the time to treat runoff from excess nutrients on the shore as you would in other regions of the bay. So there is a lot of emphasis on controlling the inputs themselves. So that would be your manure, fertilizer applications and the application rates. More emphasis on that as opposed to other BMPs that would treat the excess nutrients prior to reaching the nearest water bodies, because it's a lot shorter time to meet the nearest water bodies, or it will go much quicker into the groundwater, the excess nutrients on the shore, than you see in other regions. All right, this one here is showing the relative contribution from all the main sources to the land. So this is loads to the bay of nitrogen and the model's estimates of where the loads come from. So this is looking at the bay watershed as a whole. If you divide that up into pieces of what are the sources of that loads to nitrogen delivered to the bay, the model has estimated about 6%. This is bay watershed wide of the nitrogen load to the bay is coming from poultry. 11% of the nitrogen load to the bay is from livestock. So combined, the model estimates that about 17% of the nitrogen load is coming from manure. Also in the agricultural sector, 17% of the nitrogen load to the bay is estimated to come from fertilizer. You combine those two, so 34% of the nitrogen load to the bay for the watershed as a whole is coming from manure and fertilizer. You add in legume fixation, your alfalfas, your soybeans. So this green part here represents the model's estimate of loads to the bay from the agricultural sector. However, a portion of that load is also coming from atmospheric deposition. The sources for atmospheric deposition of nitrogen to the bay are numerous. It's livestock and fertilized soil emissions in the agricultural sector, mobile sources, utilities, and industries. Most of this portion of the pie here of nitrogen loads to the bay is coming from the mobile utility and industries. So this would be cars, trains, trucks, everything. Utilities are the power facilities, the electric generating units, and a lot of industry out there. The airshed for the Chesapeake Bay watershed is much greater than the watershed boundary itself. So these sources are numerous and they are outside of the watershed as well. There's two components to this: oxidized and reduced nitrogen. Most of the ammonia that's deposited on the Bay watershed is more local and is primarily from the animal sector, whereas NOx, which is a bigger portion of this piece of the pie here, is coming from the mobile and the point sources, primarily the power utilities. But we have seen significant reductions in emissions from the utility sector over the past 30, 40 years. This has had a considerable benefit on reductions in loads to the Chesapeake Bay. And this is primarily putting a lot of it putting scrubbers on the power utilities. This portion of the pie right here in pink represents the developed sector. So this would be fertilizer applied to turf grass. Again, we're looking at the Chesapeake Bay watershed as a whole. This is the estimate of the contribution of wastewater. So most of our reductions in our history have come from the wastewater sector. 85, this was a much considerably greater piece of the pie than it is right now. This is the current condition right here. So wastewater represents about 12% of nitrogen loads to the bay, and the remainder would be septic and stream bed and bank loads. So that is our estimates of all the sources of nitrogen to the bay based on the relative degree of the inputs, which are fertilizer, manure, atmospheric deposition, as well as wastewater and septic. The next piece is the exact same information, but now I'm just looking at Delmarva here, the bay portion, the Chesapeake Bay portion of Delmarva. First thing you notice is that this green section here that represents agriculture is greater. That's logical. There's a lot more agriculture on the eastern shore than for the bay as a whole. You don't have Washington, Baltimore's, Harrisburg's, like we do the big areas of development along the 95 corridor. So on the shore, about 14%, according to the model estimates of the nitrogen load, is from poultry. 1% is other livestock. Fertilizer is a greater contribution as estimated by the model than manure on Delmarva. So 30% of the load to the bay from Delmarva is estimated to come from chemical fertilizers. This green portion here is your legumes like soybeans. Now, a portion of the atmospheric deposition load to the bay of nitrogen would be from livestock and fertilized soil emissions. So this portion would be more applicable to Delmarva than for the watershed as a whole. But of course, there is deposition of nitrogen on Delmarva, primarily from the west for your mobile sources, utilities, and industry. Delmarva is showing a considerably less portion of load to the bay from these sources here that are part of the developed sector, which are your fertilizer on turf grass, wastewater, septic, and then stream bed and bank loads. So if you look over all the WIPs, 7 WIPs from the jurisdictions that are part of the Bay program, what we see are these general themes: protect what we have, protect our forests, wetlands, and our productive agricultural lands. The economies that are natural resource based contribute about tens of billions of dollars to the state economies annually. And there are considerable amount of ecosystem benefits beyond just reducing excess nutrients to the bay, such as habitat restoration and preservation. We need to maintain what we have. We've invested a lot in best management practices in all sectors, primarily from the agricultural sector. You put a lot invested in that, so they need to be maintained, inspected, and maintained. And the third thing that we see looking across all the WIPs is really to curtail new pollution. This would include, for example, increased agricultural animal populations. So this would be broilers on the shore, and also an increase in acres of higher loading crop types, which would be corn. But, of course, that is totally dependent on what commodity prices are. And that is pretty much it. I have a lot of references right here if you're interested in knowing anything about how the model determines or estimates these changes through time, as well as the inputs and the outputs to the land for the Bay watershed or a particular region like Delmarva. Sources here are for CAST, which is the Chesapeake Bay watershed model. There's a lot of documentation on the model. These links should all be active and should take you directly there to what is designated in these titles. There's a lot of information as well on the Bay program website for each of the tributaries. This may be of interest to you, these tributary summaries on the Choptank. A lot of the Eastern Shore tribs, lower Eastern Shore tribs. There's information on our website, Region 3, Philadelphia office on the Chesapeake Bay TMDL. And a lot of information that includes monitoring data and modeling data on something called the Bay Watershed Data Dashboard in Chesapeake Progress. And lastly, so this is all the documentation related to the Chesapeake Bay TMDL right here. So that's all I had. I don't know what time it is and how much I have for questions.
Yeah, Jeff, we have a couple of minutes. James Martin asked, are there differences in delivery to the bay from the various sources of nitrogen?
Yes, but primarily because the various sources are different species of nitrogen. So you're going to see a different chemical constituents for nitrogen, for example, on manure versus fertilizer versus atmospheric deposition. It's the degree to which you have nitrates in there versus ammonias. Nitrates can be very volatile, so you're going to see a different delivery ratio for nitrates than you would for like particulate nitrogen. So that's really the difference between most of the sources. It's really what the chemical makeup is of the excess nutrients.
Yeah, Jeff, quick follow-up, just making sure I understand the slides you presented are sources of nutrients applied on the landscape, obviously, except for wastewater, or was that delivered?
Yeah, so this is delivered, but it's based on the relative degree of the inputs. So that's over all these decades. This is the best way that we have determined to estimate what the contributions of the load, the delivered load is. When you want to include sources such as atmospheric deposition, which is important. And you can see it's a considerable piece of the pie, particularly when looking at the watershed as a whole. So these are delivered loads of nitrogen to the bay, but we determine this by looking at the relative degree of the inputs to the land and then add on the wastewater and the septic.
Jeff, this is Jason Kepler. Just a follow-up question on that. This is a post BMP implementation as well, or is this pre?
Yes, so these represent the current condition, these pies here. So this would be the 2020 condition. This, of course, changes through time. If we were looking at 1985, you're going to see a lot more red because a considerable larger portion of the load to the bay was coming from wastewater 35 years ago than it was now. So the ag sector would probably be less in 1985. Wastewater would be much greater in 1985, and the atmospheric deposition portion would be greater as well 35 years ago than this current condition that we're seeing now.
Excellent. Well, thank you, Jeffrey. We appreciate it. That's a lot of great information, and these slides are really great. It really helped me understand, how Delmarva fits into the big picture, which was a big goal of this. So we appreciate it. Before we move on to Nancy and the WIP folks, I know Alex Eccles, I believe, had a question for Lindsay or Alex. Alex, do you want to?
Yeah, I have two questions. One for Jeff. I hate autocorrect. I was trying to ask him to parse the atmospheric sources and how much of that is generated on the Delmarva versus how much of it is transported. And for example, as part of the DLLC, we've spent a lot of time thinking about ammonia coming from poultry houses, and it strikes me that where we really have an ammonia problem may be up in Lancaster and other places. So I'd love to parse understanding what those atmospheric sources are further. And the question that I posed earlier to the panelists that went before really dealt with the biologics and what are the impacts of things like pivot and Meon bio for what are the potential impacts for that on water quality, and what does it take to get those new technologies adopted as part of the Bay model?
Okay, first part of the question is ammonia on the Eastern Shore. So in our modeling efforts, in order to determine how much NOx and ammonia, so those are the two essential components of atmospheric deposition. The NOx is primarily from your electric generating units and your mobile sources and industry, and the ammonia is primarily from the animal agricultural sector. You're looking at a considerably bigger area than the Chesapeake Bay watershed on the left here. So these are the air sheds right here. Of where most of the deposition to the Chesapeake Bay watershed comes from. So we're actually monitoring much greater areas here in order to model how much of this emissions are actually following on the Chesapeake Bay watershed. The larger area here is NOx, and the smaller area here would be ammonia. So what we have in the model is actually just deposition that falls on the Chesapeake Bay watershed, including Delmarva, that may not have been originated from the Chesapeake Bay watershed. Ammonia is a lot less mobile than NOx, so you're going to see a lot more local effect of controlling ammonia than you would on in that same area than you would on controlling NOx in that area, because it does travel a lot further. There's a lot more to do with transport and transformations of the nitrogen species as it travels through space and time. Over the past 30, 40 years, we've seen quite a transition of the amount of deposition of nitrogen on the bay that comes from ammonia versus NOx. So we're seeing a lot less NOx deposited on the Chesapeake Bay watershed, and that's primarily due to controls on the mobile and the electric generating sources. So the proportion of nitrogen being deposited on the bay is increasing from ammonia, mostly because, primarily because, the portion from NOx is decreasing over the past 30, 40 years because of more controls there. However, NOx is still the predominant source of atmospheric deposition, which is coming from those sources. To give you an estimate about, it's really difficult to defensively take this piece of the pie here that I attributed to livestock to fertilized soils, mobile utility. There's a lot in here right here for the deposition to the land, and then how that is eventually transported to loads of nitrogen to the bay. On Delmarva, the model estimates that about 70%, 75% of the load total is from agriculture. So, you know, that's going to divide this kind of in half right here. And there would be a lot more ammonia in here than you would see for the Bay watershed as a whole because of the concentration of animal agriculture on the eastern shore.
Yeah, I understand that. What I'm trying to really parse on behalf of the DLLC is where should we be concentrating our efforts? And, you know, for example, you know, we've been running ammonia samplers now for 1.5 years on the bay, and we have seen spikes commonly associated with anhydrous in the local sort of sampling, but that's not, you know, a surprise. We've also found some spikes associated with new automobiles are significant emitters of ammonia. I didn't know that until this past year. And what concerns me is where should we be putting our energy? We put a whole lot into thinking about managing chicken houses. And I want to make sure that, you know, we're using a sharp tool to focus on what the source is. And so that's what I'm trying to drill down on.
So for the shore, yeah, you're going to see a bigger bang for the buck for ammonia emissions from the houses. The mobile sector, you know, catalytic converters and the change in fleets over the past 40 years have really increased that proportion of ammonia that comes from the automobile sector. So those just kind of happen because of the Clean Air Act and the state implementation plans for controlling emissions. That kind of is the effort that has been going on for a long time, that we've seen a lot of results, particularly with controlling ammonia and NOx coming from the mobile sector. So on the shore, it would be controlling the emissions from poultry and other livestock. We do credit some of those BMPs. Ammonia emission reductions is a BMP that we do credit in the model, but the states report to us annually for what they're doing. I know there are rows of trees outside the houses. There's credit for that. And the uptake that can come from those. We also have filters, I believe, biofilters on the houses themselves. That is creditable in the model. I mean, you all would probably know everything that is being done for those ammonia emission controls from the houses than I would, but I know there are a few of them that states report annually for credit in the model.
Jeff, thank you. And Lindsay, if you're still around, could you shed a little light on Alex's question about biologics? And let me scroll back up here, Alex, and specifically, oh, my chat just changed screens.
I can see it. So
okay, thank you.
You know, what are the implications of the adoption of biologics to nutrient loss, and how do we include these kinds of changes in the model? So using Pivot Bio specifically as an example, it's a biologic that allows corn to fix nitrogen from the environment similarly to what soybeans do naturally, right? And so theoretically, the implication would be that if that corn is fixing its own nitrogen, then eventually once that is, you know, proven in yield, a farmer would be able to and willing to apply less manure and commercial nitrogen to that corn crop, right? So theoretically, that could result in a reduction in overall pounds of application of nitrogen to that acre where Pivot Bio or another biologic is being used. How do we include these kinds of changes in the model? So I think, you know, that's a little bit of a tougher question. Currently, under nutrient management, under the nutrient management BMP, there are some inhibitors that are included in the timing enhancement portion of the nutrient management, best management practice. I think, however, that biologics would probably have to be a separate best management practice because they're not really a timing or a placement or a rate reduction per se. I guess you could argue that they could be included in the rate enhancement category, but theoretically they may have to be a separate best management practice that could be reported on an acre per acre basis and credited with a specific efficiency for nitrogen reduction per acre. So I guess it could go two ways, but either way, that would have to go back through either the nutrient management best management practice expert panel or a separate expert panel process. And I don't think we quite have the research available to get to that juncture yet on the efficiency of these products specific to the Chesapeake Bay watershed. The Maryland Grain Producers Utilization Board did include investigation in the efficacy of Pivot Bio and other biologics in our request for proposals this year.
Lindsay, thank you very much. Nancy, I'll get to your group in just one more second. I had Josh asked Jeff about breakdowns of that utility industry livestock portion of the graph. Now, you may have touched on that already, but can you expand on that a little bit?
Yeah, so that portion is still, the majority of it would be the utilities, mobile, and industry sector. The minority is ammonia from animal agriculture and fertilized soils. I cannot defensively tell you exactly what that split is beyond that. It's a tough question. I mean, the transport and transformations of nitrogen in this entire airshed is just amazing. The best we can do is that piece of the portion. I grouped it all together, but I can divide it a little bit further and say that it is still primarily the electric generating units and mobile and industry as opposed to animal agriculture. But that is changing through time. That animal agriculture and the ammonia from that is becoming more prominent over time.
Great. Thank you. And one last one before we move on. Alan was asking, I think it's a pretty big question, kind of an overarching theme. Delmarva has to find a 6 times the historic rate implementation reduction. What does the Bay program see as the highest priorities for meeting that goal?
Well, according to the state implementation plans, there's a lot depending on the agricultural sector. We have shifted from wastewater controls and moved towards agriculture over the past 40 years, and that is a tough one to crack.
Well, luckily we have our state whip folks coming up next who can hopefully shed a little bit of light on that question. So Jeff, thanks again. I'm sure we may have a few more questions for you when we get around the end, but Alan, I appreciate the question as it gives me a great transition to Nancy, who's going to speak with our WIP folks and some of the conservation folks. Nancy is the Assistant Director of the Harry R. Hughes Center for Agroecology. Nancy, take it away.
Well, good morning, and thank you, presenters, for some great presentations and I think we, as the members of DLLC, would all agree that there's a lot to contemplate here and a lot of work to be done in the foreseeable future. So I have the privilege to introduce the 3 state representatives who will be speaking about their state efforts, their individual state efforts to address the WIP priorities in their area, and also what practices are being put into place or looked at to put into place on specifically Delmarva. I'd asked each one of them for a short bio. I'll just say Jennifer Walls is with Delaware, and she'll be presenting Delaware's perspective. Jason Kepler with Maryland Department of Agriculture will be speaking for Maryland, and James Martin for Virginia. I'm going to ask each one of them to provide a brief introduction of themselves. I was curious about all the acronyms related to what their individual departments were, but we'll go ahead and start with Jennifer. We're doing it in order alphabetically by state. So Jennifer, thank you.
Thank you. My name is Jennifer Walls, and I'm a principal planner with the Division of Watershed Stewardship at the Department of Natural Resources and Environmental Control in Delaware. With the exception of a 2-year break, I've been with DNREC for about 18 years, and during that time, spent most of that time focusing and never really getting away from focusing on watershed planning and implementation of TMDLs and pollution control strategies. I've been involved in some way, shape, or form in grant management related to the Bay, implementation of projects, working with local governments, working with our ag sector partners in a variety of ways, looking at stormwater management and drainage efforts, and then also looking at wastewater initiatives. So I've been around the department quite a bit and had the opportunity to work with a lot of our folks across sectors. That said, we've had quite a bit of transition within our department lately. Many of you may know Brittany Sturgis. She is no longer with us, but our new Chesapeake Bay implementation grant manager and implementation coordinator is Molly Dworkin. And Molly is a recent hire, so she's still learning all there is to know about the Bay and the efforts that we're working through. So in the future, I expect you'll be hearing more from her. My role is to help coordinate and facilitate our Bay program efforts as well across our department and within our partners. So that's kind of where I'm at currently. And was there anything else you wanted me to touch on, Nancy, before I get into the, okay.
No, go ahead.
I apologize, I did not share my slides ahead of time, but I am going to attempt to share them now, if that's okay. And let's see if this works. Okay, so I know one of the questions that you had asked us to highlight on is the BMPs that we are focusing on. And I want to say that we continue to focus on tillage practices. I think that's one of our successes. We're doing well there. Of course, nutrient management, soil health initiatives, and cover crops are all priorities for us. We continue to be challenged in implementing buffers and wetlands. I think just like everyone across the peninsula and within the Bay watershed. And then some opportunities that I believe that we may have moving forward could be with additional drainage practices, improving our manure transport, and potentially septic connections as well. And septic, obviously not in ag, but septic is another area that we have some opportunities, I think, moving forward to evaluate. A couple of some challenges and successes that we've been focused on lately. we're challenged with losing credit in the model due to some of the lifespan and duration concerns. So we're working, obviously working through that with our partners. We've had some challenges with our database and our BMP verification, which is also related back to the model, which we're working through. We've had some challenges with maintaining existing practices, particularly our CREP practices, and implementing new CREP practices. So that's always a challenge, or that has been a challenge. And then having folks willing to adopt new practices, engaging landowners to adopt new conservation practices, particularly buffers and wetlands. It's difficult. Our capacity, both ours and our partners, obviously there's, as Jeff mentioned, we, in the next 5 years, we're going to need to see a 6-fold increase in implementation, and our capacity at the state level and within our partners is going to be a challenge, moving forward. I do want to recognize the partnerships that we have. Delaware is a small state, and that affords us the opportunity to work closely with all of our partners. And I think we do very well with that, supporting the work that they do, and they support the work that we do, and but whether it be financially or on the ground. So that is certainly a success. And then I also feel that another success that we've had is our cover crop transect survey program. I think that's been a really important initiative that has really helped us in capturing some of our practices on the ground and showing those trends. So, and I think that program continues to improve. And then my last slide, I just wanted to touch on, I think we were asked to touch on some initiatives and opportunities. So some things that we're working on moving forward. We have staff that have been working on developing a BMP guidebook. I think like many of the states, we have multiple resources to look to for practices. And so we've had staff working to put together just a more comprehensive and updated guidebook for practices that we can share with landowners and partners, and that's more consistent. We also have some local government initiatives, and some of the folks that have been involved in this big one are on the line. So I think Chris and Chris Basin and David Baird can speak towards this, but Sussex County recently, as recently as I think a week or so ago, introduced a wetland buffer ordinance for the county. Obviously it's not adopted yet, but it's a step in the right direction towards protecting what we have already on the ground. So I'm excited and hopeful that that's going to move forward and benefit us within the coming years. And then we've also, going back to partners and local governments, Delaware has a very small urban land use. So, but we work very closely with our friends in Laurel and Seaford, and they've been implementing some pretty major restoration projects in their communities. And I think, we've been able to help support that through different financial resources and technical assistance. And, it's been there's been multiple benefits, I think, for them as well as for us. So I think that's important to note. And then, I see coming forward, we've seen applications and discussion of some new alternative use facilities for poultry litter and mortality. I mean, there's been talk about rendering, of course, but also some energy generating facilities that have the capacity to take some of the litter on the peninsula. And it's still to be seen, I think, how effective that's going to be in helping us with some of our litter. But I do think that it's an opportunity that we should pay attention to. And then, we'll continue to evaluate additional opportunities to extend sewer and reduction of septic systems. And then, looking to co-benefits and using and identifying co-benefits to help incentivize adoption of practices. So I hope that captures everything you were looking for. If there's any questions, I'd be happy to take them now or as we move forward.
Yeah, that's great, Jennifer. We do have one question. Alex Eccles asked the question, can you talk more about the potential in Delaware for more widespread adoption of conservation drainage practices?
So we are our drainage program is working through some initiatives to look at look at the drainage systems and identify practices and opportunities for practices. So something we've been looking at for a while. And that kind of gets to co-benefits. The main focus of that is drainage for residents. It's flooding. It's a lot of things, but I think there may be opportunities there to identify, maybe some restoration or buffer opportunities, or how we can incorporate some of these other practices into our drainage systems. And it may not be infield drainage, but maybe it's, our tack stitch drainage system. So it's still to be determined, I think, but it's an opportunity that I think we need to pay attention to.
Well, thank you so much. And now we're going to move to Jason Kepler in Maryland. Fast tour throughout the Delmarva today.
Good morning, everyone. Jason Kepler, Maryland Department of Agriculture. So I've been with the department since '97, serving in various capacities. I've actually had a few brief stints away working for some other agencies. So I served with the department in various roles, started out with our cost share program and kind of migrated up. I'm currently the program manager for our Watershed implementation program. And I'm also the acting program manager of our conservation grants program, which includes the Maryland Agricultural Water Quality Cost Share Program, which is affectionately known as the capital program. So that involves implementation of structural practices on the landscape, as well as our cover crop program, manure transport program, and other things. So got my hands full with a bunch of stuff. I'm also the immediate past chair of the Ag Work Group for the Chesapeake Bay program partnership, and currently serve as the vice chair. I think that's what it's called, James, if I'm not mistaken, the vice chair of the water quality goal implementation team as well. So I got my hands in the Bay program side too. So I'd like to give a brief overview of where Maryland is in terms of meeting our responsibilities under the TMDL for our WIP 3 plan, and more specifically how the practices being implemented on Delmarva contribute to the overall success of the state's plan. So Nancy, I provided slides. I'm not sure if you guys want to pop those up, or should I share my screen? Not sure how you want to do that.
Probably best if you can share your screen.
Okay. Can everybody see my screen now?
Yes.
Okay, great. So real quick, I chose the top 10 practices that are important to the state's overall WIP. Top 10 practices being implemented on the Eastern Shore of Maryland. So if you take a look at this table real quick, there are a series of practices, the units of measure, and then the third column in is the percent towards meeting the state goal. So these are practices that contribute greatly in meeting the overall state goal. So in the case of ag drainage management practices, 99% of all the practices identified in our WIP actually need to be implemented on the Eastern Shore. So you can see the relative importance, ag drainage management being the top, and we go down through the list with animal waste management systems, wetland restoration, et cetera. The next column over is our percent progress towards meeting that goal by 2025 for the Eastern Shore. So in the case of ag drainage management, while 99% of the practices need to be installed on the shore, we've only been able to achieve 35% of that goal as to date. So again, there are some opportunities for us to further increase adoption of conservation measures on the Eastern Shore, but you can see the practices in green. We've had a high level of implementation already, and we hope to increase that implementation out to 2025. As was indicated in Delaware, ag drainage management, I think, is going to be a significant contributing factor in helping us meet our overall WIP implementation goals. There's another practice, ag stormwater management, which you'll see is red. There's 0% progress, and that's not because we haven't done anything. It's just simply an accounting mechanism that we need to work on. So this was a new practice that was adopted by the Chesapeake Bay partnership that allows for us to account for stormwater management on poultry farms specifically. So this is something that that we hope to better quantify moving forward, and I hope to have better information out to 2025. Key programs, obviously, for us, not only on the Eastern Shore, but across the state as a whole. Our cover crop program is one of our key programs in meeting our restoration goals. On average, we implement anywhere from 400 to 450,000 acres annually across the state, to the tune of over $23 million annually. So it's a huge investment for us. Soil conservation and water quality plans. These are the backbones of everything that we do in addressing resource concerns on farms. So obviously those are important programs as well for us. And then, we really need to recognize the importance of buffers, whether that be grass buffers or forest buffers, and implementing that on the landscape as well. I know there's been a lot of discussion about implementation of additional forest buffers that is not as attractive as perhaps some other options over on the Eastern Shore. So if you look at the implementation and what we've developed as part of our plan, about half of our forest buffer implementation across the state was identified to occur on the Eastern Shore. And we've almost met that goal, 91% towards meeting our Eastern Shore riparian forest buffer goal. So while there's a lot of work in that forest buffer space, especially on the shore, we think that we're close to meeting the overall implementation goals that we established when we developed our WIP plan. So maybe I'll just stop there, and then as I continue with the presentation, hopefully maybe it'll provide some clarity on where we want to go with some of these BMPs, and then obviously address any questions that you might have at the end. So the next slide. What are some of our challenges? Obviously, over the course of the last year, COVID has been a huge challenge for us. Not only in terms of our workforce not being able to go out and work with farmers to identify those resource concerns, but then we're also dealing with some of the supply chain issues that we're all hearing about now, and really that goes into the cost of implementation of putting these projects on the ground. Let me just start with the material costs right up front. Material costs have gone up significantly, and for those that are putting practices on the landscape, for anyone that's trying to build a house or do home improvement projects, the price of lumber and everything has gone through the roof. In some cases, up to 80%. So that's really had an effect on our ability to implement additional practices on the landscape. And then those opportunity costs as well. We recognize that there's been a historic level of implementation that's occurred since 1985 on the landscape. And I wouldn't say that we're running out of opportunities, but all the low-hanging fruit, I hate to use that term, but a lot of the low-hanging fruit has been picked already in terms of trying to identify areas to put these practices. So it's really encouraging those that have been that haven't participated in the past. What is it going to take to perhaps encourage them through incentives or other things? Encourage them to adopt those conservation practices on the landscape. So it may not be just providing cost share assistance, but providing incentives on top of that. And I'll talk a little bit more about that in a minute. One of the other challenges, and I'm sure this is recognized across the watershed as a whole, is the I'm going to say the relationship between landowners and tenant farmers. I would say, Lindsay, correct me if I'm wrong, but I want to say that it's close to 40 or 50% of the land is actually rented land as opposed to owned by the farmer. I see you popped up, so I'll just stop there for a minute.
Yeah. So in the 2017 census, it was actually closer to 60-65% rented land on Delmarva specifically.
Thanks for being my statistician. But that in and of itself represents a challenge, especially when we're talking about long-term implementation of long-term projects. The farmers that till the land may not have a long-term commitment for that land, so they are unlikely to apply for cost share programs that may commit them to a 10 or 15-year contract. And likewise, we have many situations where we have absentee landowners that may not understand the importance of conservation and really rely on the farmers to do that for them. So it's really overcoming those barriers, educating the landowners, et cetera, in that process. Potentially competing programs. We all want to have a clean and restored Chesapeake Bay, and we all have our own thoughts about how to go about doing that. There's many different grant opportunities out there, and different organizations want to help. But sometimes, they may ultimately end up in competing against one another for projects. So I think that there's opportunities for us to work together collectively and making sure that we're best utilizing all the resources to achieve the common good here. And then finally, obviously, climate change is becoming an important factor. We all recognize that, not only in terms of changes in the landscape and how BMPs may or may not become more or less effective on the landscape, but then also as it relates to saltwater intrusion and the effect of seawater or inundation on agricultural landscapes, and what that might do, or how that might affect ag on the Eastern Shore. So how are we going to try to address some of those issues? Well, one of the challenges that we had was a capacity issue with our conservation district folks. There's a recognition that there was a shortage of technical assistance on the not only on the shore but across the entire state. So we needed more folks to go out and work with farmers to address their resource concerns, et cetera. So we were able to secure 53 additional positions in our conservation district office, state-funded positions, to help with that. So this gives on average, a conservation district 2 or 3 extra folks out in the field to help out. So these are our planners and technicians, the boots on the ground to get the work done. And I'm proud to say that we are in the final stages of hiring the last 10 of those 53, I believe. So a lot of work has been done, and over the course of the past year or two. And I really want to thank everyone that was involved in helping push that effort forward. So that was a huge benefit for us. Number of pieces of legislation, without getting into too many specifics with this. There was a bill that was passed last year called the Natural Filters Bill, Fixed Natural Filters Bill, that expanded the opportunity in terms of the types of practices that were being offered to the Conservation Grants Program. So we've added pasture management practices, silvopasture, other fixed natural BMPs, tree plantings. So it goes beyond just our normal suite of practices that we were offered. This past legislative session, there was a departmental bill, Senate Bill 344, that passed that increased the max cost share assistance from 87.5% up to 100% cost share assistance. So this is a huge opportunity to help us implement additional practices on the landscape. There's obviously some strings attached to that 100%. Farmers are required to have a conservation plan, and then the practices that we're paying for up to 100% are those that have been identified as key practices within our WIP program. There was a Clean Water Commerce Act bill that was passed that essentially carves out $20 million from the Bay Restoration Fund to help support pay for performance types of initiatives. And 35% of that $20 million, or roughly $7 million, is specifically ear tag to help pay for the implementation of critical BMPs on the ag landscape through a pay for performance type option, which is different than our normal cost share program. And the priority practices included in that are not only these fixed natural filters practices, but also ag drainage management. So there's really an opportunity to bump that ag drainage management implementation up using these funds. And then finally, another piece of legislation was the Tree Solutions Now Act of 2021 that was passed. that essentially requires the state to plant 5 million trees by 2031. So the Department of Ag specifically will receive $2.5 million per year to provide an incentive of $1,000 per acre to farmers that sign up for riparian forest buffers through the CREP program. So this is, in addition to implementation money, this is an incentive payment. You will get $1,000 per acre if you agree to a 10 or 15-year contract under CREP for riparian forest buffer. So again, another incentive to help us get over that goal line by 2025. We have some pilot programs that we're considering. We had a conservation buffer initiative as an alternative to the CREP program that provides a little bit more flexibility to farmers. Again, I mentioned the pay for performance option with ag drainage management. We have a soil health program that is evaluating all the practices in terms of additional benefits, not only for water quality, but to increase soil tilth and other things. The state has a Greenhouse Gas Reduction Act plan that we have to account for carbon sequestration, and many of the projects that we're implementing on the shore and other places actually help contribute to that carbon sequestration. And then finally, Maryland has a saltwater intrusion plan that we're putting together to help address those concerns with saltwater intrusion. So that was a lot in a nutshell, and I apologize for going fast. I know we're kind of short on time, but I'd be happy to take any questions that you guys have.
Are there any questions? Jason, that was great. And don't worry about time. I think these sessions are really important because we're getting into the nuts and bolts. One thing I would add to what Jason talked about at the state level, the state is in the process of looking at a climate vulnerability assessment for agriculture in Maryland. They are in the process of having an outline proposed for what would be studied and what that assessment would look like. So I would suggest, if you're interested in that legislation, the Hughes Center was named, MDA was named, MDE. Please get in touch with somebody, and if you do have suggestions, that would be very helpful. And I can forward, we're also asking anybody in the ag sector to complete a survey, so I can certainly send you the link.
Thank you very much, Nancy, for bringing that up. That was, it's going to be an important component of us, helping address some of these initiatives moving forward. And one other thing that I failed to mention that I should is our Animal Waste Technology Fund that Alicia Mulkey manages. There's a RFP on the street currently, and that there's dedicated funding to support grants that look for alternative uses for manures, and especially poultry litter as well. And I should mention that our Manure Transport program has been another banner program for us. Last year, we transported 84,000 tons of poultry litter using that program, and 65% of that litter was actually transported to alternative uses. So, I mean, that's another great example of a program that's been successful over the years.
Great, thank you, Jason. So our last speaker in this segment is James Martin from Virginia. James is the Chesapeake Bay Program Manager for Virginia's Department of Environmental Quality, but he is also the current co-chair of the Bay Program's Water Quality Goal Implementation Team. So he works with jurisdictions throughout the area. So James, thanks so much for joining us today.
All right, had to figure out how to unmute once I started sharing my screen. I hope you can all see it. All right. I'm not hearing anybody telling me they can't, and I can't see you. So I will march ahead.
We can see you fine, James.
Awesome.
Yeah.
Awesome. Thank you. I'm with the Department of Environmental Quality in Virginia and have been working with Jason and Jen and the other Bay states and Jeff at the Bay Program Office for a number of years now. So it's interesting having seen the other presentations. I'm sure you will see many commonalities in terms of our approaches to addressing these loads in Virginia, and I think that's kind of one of the little spoken benefits of having the Bay Program partnership is the ability to share best practices and what's working and what's not among the partner states. So to put a little finer point on Jeff's presentation, this is what it looks like in Virginia, Virginia's portion of the Eastern Shore Bay drainage. Since 2009, we've been able to reduce about 300,000 pounds of nitrogen, and that's over 11 years. And over the next 5 years, we've got 571,000 pounds left to reduce, 83% of which are reductions expected in the agricultural sector. So half the time, twice the amount, about a fourfold increase in effort for Virginia's portion of the Eastern Shore. Of that 83% of load reductions actually has to come from only about 40% of the landscape. So we're fortunate to have a good portion of Virginia's Eastern Shore still in natural land uses, but we do have growing developed lands as well as significant agricultural lands on the shore. And can't let the Eastern Shore pass without also mentioning about 40 million chickens and their litter that are in Virginia's Eastern Shore Bay watershed, almost all of which are in Accomack County, one of the two counties on Virginia's Eastern Shore, the northern of the two counties. This is important because the model that we've been talking about here, wherever a chicken lives is where that chicken litter is applied, unless we tell the model otherwise. So some of the programs we've been using and are focused on in Virginia are not that different than the ones you've already heard about: cover crops, nutrient management plans, animal waste systems, tillage, soil conservation plans, buffers, and litter transport. We also have an agricultural cost share program in Virginia. It's administered through our Department of Conservation and Recreation's Division of Soil and Water Conservation in partnership with soil and water conservation districts across the state. Our phase 3 WIP in Virginia significantly expanded our poultry litter transport program, and also tried to bring our agricultural BMP loan program, part of our state revolving loan fund, more into play to help address some of the objections to participation in cost share programs from producers about having to pay for practices up front and then be reimbursed. We're trying to use this loan program to offset that concern. We're also focused on making sure we're trying to document all of the practices that are already happening on the ground. We're doing this through our conservation planning efforts and resource management plans. We've tried documenting voluntarily installed practices through a farmer survey over the past year. Results of that are about to be finalized and submitted with our next year of annual progress data. And like other jurisdictions, we use transect surveys to try and document tillage practices and cover crops throughout the watershed. So some of the key takeaways for Virginia: a lot of progress has been made, as Jeff said, but much more progress is needed over the next 5 years in order to meet those goals. Most of those remaining reductions are expected and planned to come from the agricultural sector, particularly on the Eastern Shore. But practice on practices on existing developed lands, particularly unregulated non-MS4 lands, are also needed. Efforts to track poultry litter from its point of origin to its point of land application is critical. Again, the model thinks that litter all stays in Accomack County from 40 million chickens if we don't tell it otherwise. So one of the recent changes to our poultry general permit and our poultry litter end user regulations is to implement a new reporting system and to actually require that reporting annually. The permit is, both of those permits and regulations have long had a data holding, a data keeping requirement. And then the data was collected during inspections, but this is putting a more proactive approach to collecting that information about where poultry litter is moving around the Commonwealth. And then we need to continue our efforts to manage nutrient loss from cropland. Nutrient management plans, particularly those enhancements that Lindsay touched on, enhancements to rate, timing, and placement, such as split applications, precision applications, and offsets from water features and other environmentally sensitive areas are going to be key to our success as well. There's my contact information currently, though I'm happy to announce that effective November 10th, I will be shifting from DEQ over to DCR to lead that division of soil and water conservation that implements our agricultural cost share and other programs to control nutrient and sediment pollution. So thank you for the opportunity to join you today, and I look forward to your questions.
So does anybody have questions for James or any one of the panelists? And James, congratulations. I guess I should say congratulations.
Yes, of course. Absolutely.
Okay.
Thank you very much.
So no questions? Okay, well, if we don't, thank you, all three of you. We will move to the next session of panelists, which are really our local implementers of these state practices and work very, very closely with the producers in our communities. And I think there may be questions after this group for this earlier session panelists. So I'm going to start by introducing, once again, we have representatives from each one of the states, and they're all very familiar to all of you. David Barrett will be representing Delaware. He's from the Sussex County district. Jen Nelson, who will be representing the Maryland Association of Soil Conservation Districts, and Nick Thomas, who is also a member of DLLC. And he's actually talking from his perspective as a member of the Eastern Shore Soil and Water Conservation District in Virginia. So again, David, we're going to let you lead off as the Delaware representative.
Great, thank you, Nancy, and good morning, everybody. It's been an informative session so far, and hopefully we'll do a good job of wrapping this up and letting you know what's happening on the ground. Obviously, we've heard a lot about the practices that are critical to each of the states in implementing the WIP. Some of the ones, at least here in Delaware, that most of our farmers are interested in, definitely the cover crop program is our flagship operation, and we're seeing great participation now and incremental increases in that participation. And I think when you look at the Delaware Conservation Partnership, that's an area of focus for us, is how do we pick up those late adopters in the cover crop program. Also, the high on the list are water management and drainage management. Folks right now know that they have problems and that it's an issue. They're not completely sure of what the solutions would be. And if they do have an idea on the solutions, it's, deal with it as quickly as possible and not really look at the opportunities that are associated with that. So, but that's a huge priority. And obviously during periods when it's wet, it becomes even more of a priority. And then the last thing that's really taken off for us over the last 6, 7, 8 years has been our soil health program. And what we found with that is that there is a lot of pent-up interest amongst the agriculture community, and there is an appetite for information for soil health initiatives and practices and just any type of information that's available. So we're finding that folks are willing to, not only listen, but try to incorporate some of those principles and practices into their operation. How do we get all of this done? It really boils down to communication has to be high on the list. The communication between our partnership here in Delaware, and I'm going to refer to that as, obviously our federal and state agency partners, but also landowners and then other, NGOs or folks who are participating in this arena. One of the things we try to do as much as possible is make sure that whatever information we have is getting out there to the public and our partners. We're also seeing an uptick in funding from our state agencies. Just a couple of years ago, the Department of Agriculture was successful in putting almost $3 million in for additional cover crop funding. And that has held over the last couple of years. We did have a little setback a year ago, but we're right back up to those levels. And with the adoption and passage of the clean water funding legislation by our General Assembly earlier in the year, I would anticipate that there'll be some increased opportunities, not only for agriculture, but also for conservation in general and overall water quality here in Delaware once that gets off the ground. So there's going to be obviously some setup time to get that started, but I think those are some good things that we're seeing coming down the road. As far as barriers that we face on a regular basis, while the funding is improving, it's still a challenge. As we've talked about earlier today, is that funding for the ag folks is always a challenge, especially now when you're looking at costs increasing the way that they are in just about every possible input there is into an agricultural operation. That's only going to make things much more challenging for us. And we're starting to see some of those impacts already. But I would say that, another challenge is just making sure there are opportunities for folks to engage in conversations and that there are resources that are out there. And that goes to, what are those available practices? How do you fund those available practices? What are the needs that I'm going to have to incur as a landowner or an operator on that land as far as maintenance or, just maintaining those practices going forward? Another barrier that we get feedback on is just how complicated some of these programs and funding sources can be, especially when you get into the federal government programs through NRCS and sometimes FSA. It just adds a layer of complication that many people just don't want to feel or deal with. So there's another challenge and barrier that we're constantly trying to work through with the operators and growers here in Delaware. And then I believe that Jason had brought this up earlier as part of his comment. It's something that we're cognizant of here, especially with rising land prices, is just the tenant landowner relationships. and what that means. Where Delmarva is all of a sudden, just a highly desirable area for, more people coming here and residential development, which increases land values and the likelihood of some of these landowners wanting to enter into long-term leases where, a farmer can go out and do some work and make a long-term investment. It's getting harder and harder for them to do that. So that's certainly a barrier that we see facing us as it relates to that. Of course, the biggest question becomes, how do we address that? The approach that we've taken has really been making sure there are boots on the ground. We've been very fortunate here in Delaware and especially Sussex County that we've been able to build great partnerships with our state long-term as far as funding for agriculture conservation planners. We also have been able to take advantage of some other opportunities through whether it be state agencies or NRCS or others out there to help provide, funding and other necessary resources, not only to hire folks that can be on the ground, but give them the resources to do their job. And then ultimately everything comes back to relationships. And we always say that we wouldn't be successful at all if we didn't have good relationships with agricultural producers in our county. And then just kind of trying to wrap this up, some of the examples that we show and successful examples, I think many of you have seen or even participated in. And those have been our soil health workshop series that we have had over the last couple of winters. And then we also have our soil health summit that is taking place in February and scheduled to do that, where it really creates an opportunity for people to come in, listen to some of the experts in the field on these various issues, and also a place where they can come and exchange some of the thoughts and ideas that they have running through their heads. We're doing the same thing on the stormwater side of our shop in putting on a series of workshops and other outreach for homeowners associations, and everybody else in the development sector, because we recognize that that's equally as important as it is in the ag sector. And I know we're here to focus on the ag sector today, but I can't stress enough that really what we pride ourselves on and where our focus always comes back to is making sure that we have good relationships with the people that we serve here in our county, and just trying to do whatever we can to make sure that their voices and input is being received and working its way into conservation policy here in Delaware. So I'll wrap up there, and I guess we'll hold everything for questions after everybody's done.
Thanks so much, Dave. That was great. And I see that Jen Nelson put the link to the Soil Summit information in the chat. And I'm also going to just reference the Hughes Center actually has done a lot of work over the last 3 years with conservation leasing practices and conservation leasing, trying to get tenant or the farmers on leased land speaking with their landowners. So if you're interested in that work, I'm happy to talk with you at another time about it. But if you also go to the Hughes Center's website, there is a guide that you could share with, we've shared it with the soil conservation districts and others, and we'd be happy to work with you on that project. So with that said, I'm going to turn it over to Jen Nelson, and she is going to talk about Maryland mainly, but she does work in both Delaware and Maryland. So thanks, Jen.
Thanks, Nancy, and thanks, David. I'm fortunate to work with Dave quite a bit in Delaware on their soil health outreach and just with the conservation districts in general. So he did a great job describing the perspective there. So I can focus pretty solely on Maryland here. And I wanted to actually start from kind of not a soil science perspective, a social science perspective, because I think that we've had a lot of really technical details so far in the conversation today. And from a farmer's perspective, I think the practices that they are interested in are things that are a good fit for their overall farming operation. So if they can see that something offers a clear benefit to their operation from a financial standpoint and from a time management standpoint, and it's something that they can fit in and see fitting into their operation, that tends to be where people will go. And so a lot of the practices that we've talked about so far, including cover crops and the 4R practices and conservation drainage management, and even irrigation, are things that kind of fit that description. So you can see a clear benefit from a soil health standpoint, from a funding standpoint. And in Maryland, I think one of the things, one of the reasons why that cover crop program has been so successful includes that it's been a pretty fully funded program. So it's been consistent over time. Farmers don't have to worry about whether or not funding is going up or down so much in any given year. There's not a cap where they have to try and calculate how much acreage they have available to plant. You know, it just makes it that much easier for planning. And also, I think farmers are looking for practices where there's sufficient information available to make a decision as well, especially with cover crops. As you get into some of the enhanced management sort of situations where you're planting earlier, where you're terminating later, and things like that, you want to know that the information is there so that you are doing a good job with that and you're reducing the risk or perceived risk to your operation. And so Jason touched on it in his presentation, and I saw Lindsay chime in the chat box with the additional positions funded through Maryland in this past year. And so I kind of came on board with Maryland after all the hard work was already done there. So I have gotten to witness kind of the hiring process that's gone on with all of that. But the heavy lifting was done before I got here. So I'm sure that I can appreciate it, but not as much as Jason and Lindsay can, from Lindsay's past position with MASCD and Jason's current position. But those boots on the ground and the soil health outreach and things like that, those are really important components in working with farmers, so that farmers can explain the benefits to other farmers, so that the conservation professionals can articulate management strategies and talk about what they've heard from other farmers. Like, those are really important pieces for farmers to be able to envision how something is going to work on their specific operation. Okay, so kind of along that same line then, things that are barriers to practice implementation, there are competing priorities. So time management is huge. Weather plays into that probably more than we would like to admit. Lindsay talked about, weather variability and weather when it came to yields on her farm, but it also has a huge impact for annual practices on practice implementation. So, that's something that we have to keep in mind as well. A lot of rain in the fall or something like that, it's going to push back harvest. It's also going to push back the window that you have available for cover crop adoption. And so I am going to talk about Delaware just for a second there, because my familiarity is more on the acreage data in that state. But when you look at kind of the variability in cover crops over time, you look at a few different things that really kind of influence the adoption of that particular practice. And that's the funding that's available. That's kind of number one with a bullet. You see weather has a big impact as well, if the conditions are right to get in the field to plant cover crops. And then you could see, especially when funding was flat over time, the soil health outreach component really did have an impact in that window before we had a big influx of funds from the Department of Agriculture. So you can see those three things working together and impacting the implementation of that specific practice. So farmers are also looking at the perceived risk of adopting a new practice. And I think that comes into play with soil health practices, but also with our 4R practices. So they're looking for things that reduce risk, and they kind of shy away from things that they think increase risk in terms of yield loss and things like that. And so I think there's also a little bit of a status quo bias. If something is working on the farm, it's kind of hard to get somebody to break away from that to try something new. And I also noted something about decision-making authority. So we've heard in some of these other presentations, people talk about landowner and tenant relationships, but even on the land that you own, if there's more than one decision maker on a particular farm, one person might be willing to adopt a new practice, but other people in their family or other decision makers aren't on board with trying something new. You've got different personalities that are at play here. And I think those of us who are on the phone, many of you can probably appreciate how hard it can be sometimes to get consensus on a decision. And so that plays in as well. And so I think that some of the suggestions that or recommendations for moving things forward, that education and outreach focus is really important. One thing that I would suggest specifically is that we work hard not to always put up our early adopters and our innovators in some of these peer-to-peer knowledge transfer type events, because it's not clear that that always resonates with middle adopters or people who are a little later to bring on a new practice. And that gets back to that risk management piece. So you want to talk about new practices in the sense of how common they are, how they reduce risk. And it's not hard to kind of make a switch in your head for framing up a conversation that way, as opposed to things that excite us that are new and innovative and interesting. And focusing on that return on investment for new practices as well. The second recommendation is just coming back to funding, making sure, I think Maryland has done a really good job with this, both with their cover crop program and with the new initiative to fully fund some of the other conservation practices that we're struggling with a little bit. But that piece, I think sometimes I equate this one to like diet and exercise for losing weight. You sort of know what the right answer is. Sometimes it's just not the answer that you want to hear. And so you sort of look for other things, but you come back to some of the basics when it comes to funding practices and moving those things forward. That's a really important piece. And so one of the other things that I was looking at is the emerging issues with diversity, equity, inclusion, and justice. So there have been some initiatives to bring informational materials. I know Sarah Hirsch is working on a project called Cultivating Conservation to reach out to beginning farmers and participants in the Women in Ag program to make sure that they know about NRCS and conservation districts and all of the financial and technical resources that are available there. I think that's another opportunity to move things forward. And finally, if we are going to look to branch into some of these innovative ideas, if there are ways that we can increase capacity either on farms or within the private sector to loosen up some of those constraints, the time management constraints, or funding constraints or informational restraints on a practice adoption, I think that those are potential solutions that we have to look into as well. So that was a lot. I don't know if anybody has any questions there, but that is about all I have.
Well, that was great, Jen. Thank you. Alex does have one question, but I'm not sure in the chat if it's for you or someone else.
Read it and see.
It says on risk reduction, there's a pilot program in 11 Midwestern states that reduces crop insurance cost. And is there anything similar being, well, okay. For corn
So
producers,
the background on that is the RMA announced last month a reduced crop insurance rate in 11 states for people to use split nitrogen application. We're not one of those 11 states. Is anybody working on broadening that discount to our farmers?
So I was going to say, Lindsay, you look like you might be able to address that one.
Sure. So, Alex, thanks for bringing that up. Just to clarify, it's offering coverage for farmers who are splitting their nitrogen for yield loss if weather impacts ultimately disable them from applying all of the nitrogen that they had planned, right? So say you were normally putting on a fall application as well as a pre-plant application, and that's all your nitrogen, right? If you are willing to split that nitrogen and plan to do a side dress or an in-season application, but it rains or you have a drought and you can't get that last application of nitrogen on, then the crop insurance would cover yield loss due to not being able to get all of the nutrients on that crop would need. And so I'm in contact with the National Corn Growers Association affiliates across the 4 I-states to get some information on adoption and implementation under that program, and then hopefully chat with FSA and RMA about expanding that after the pilot is complete next year.
Thank you, Lindsay. Okay, it doesn't look like we have any other questions, and I want to make sure Nick gets to talk. Nick,
Good morning.
thank you for being patient with all of us.
No, you're fine.
So I'm just going to let you introduce yourself and talk about Virginia's efforts on the local level.
Yes, thank you. Good morning. My name is Nick Thomas. I am a poultry and grain farmer in Northern Accomack County. Also the vice chair of the Eastern Shore Soil and Water Conservation District Board of Directors. I wanted to talk with you guys a couple minutes about implementation barriers and some success stories that we're having. Our first barrier is we've had a misunderstanding of programs between NRCS and state. Many applicants believe that there's a higher funding percentage with NRCS on certain programs, which is generally untrue, but we've been unable to curb that myth, and we've had to send money back to the state because people just didn't apply with us. They went, projects went unfunded. Our next issue is going to be the funding itself, where it's highly volatile. Our funding can swing 200% from year to year. This is hard on district staff and workloads. And this also causes uncertainty in the farming community about planning for future years and whether they will have the funding to implement BMPs. We also have a funding split directly down the middle of our, literally directly down the middle of our district, with 70% of the funding going to what we call Bayside and 30% going to Seaside. This turns off many Seaside applicants as they fear, such as this year, that there's a funding shortage on our Seaside programs. An example of this would be we currently have 10 contracts for manure storage projects on the Bayside and only 1 on the Seaside. And that primarily came from additional technical assistance money that we were able to pull together. Now, while the actual manure sheds themselves are on either the Bayside or Seaside, and it does resolve some issues on farm, the actual manure that is being stored so that it can be applied timely in the spring is being distributed equally between the Bayside and Seaside. Some of our successes that we've had recently, the staff has done a great job at reaching new applicants for cover crop programs. We've had record signups year over year for the past 3-4 years. Our VCAP program is kicking off and receiving quite a bit of interest. This is going to be primarily our living shoreline projects. We're getting better implementation of programs and understanding of the benefits. We're getting them in earlier. We're getting better growth on the cover crops. Many of them are being let mature to have a longer growth cycle. It used to be that our program would let you burn down on March 1st, as it does now. And March 1st, the sprayers would come out and everybody would go in and kill the cover crops. But we're seeing a lot of understanding on the benefits of letting them grow until either right before, or we're having many applicants that are planting green into their cover crops. That's all I got for today. Any questions, I'd be happy to help.
Anybody have questions for Nick? So I think we have a few minutes, and Kevin will probably move to the general question and answer session. But does anybody have questions for anyone in the last session?
Hey, Nancy,
Kristen?
this is Kristen. I just wanted to get folks' take on, I mean, what I heard Jason say, and Jason and James and Jennifer say was there's a lot more work to be done. So I'm really curious to hear from the conservation professionals, like, are you thinking that's possible to get that work done? Or if not, what you would need to get that done, obviously, aside from a magic wand?
Kristen, this is David. I'll take a crack at answering that first. I think it is possible to get things done, but I think we as the conservation districts or others on the ground, need to look at new ways of delivering the services that we provide. Doesn't mean we throw everything out, but we just can't continue to do things the way we have in the past. I know here in Delaware, our staffs are really integrated tightly with NRCS, and we find ourselves working on NRCS priorities a little bit more than we would like sometimes. And we've got to do a better job of breaking away from that and really addressing more of those local needs that are out there.
Go ahead.
No, I was going to say, do you want to chime in? I was trying to look through the squares.
I was just thinking, I agree with David about looking at new ways to provide service to our cooperators. And so I think we're looking at if there are increases in funding that are available and increases in outreach and education, and being able to frame practices in a way that they provide that clear benefit to an operation. The opportunities are out there, but those are the components that are necessary to make that happen.
So does anybody else want to chime in on that? So Jason, I have a question for you, not to put you on the spot, and looking at the amount of work that we need to do on the Eastern Shore, looking at Jeff's numbers, and then the fact that MDA does have new staff, what are the plans? And I really am not trying to put you on the spot, but what are the plans, or are there plans to look at where the ag reductions are going to be emphasized, and to provide staffing accordingly.
Yeah, so to answer that question, Byron Petroskas, who's our district operations manager, they did an entire workload analysis to determine where the best utilization or where the need was for those additional positions. So I mean that analysis was performed. And, like I said, it's a combination of both planners and technicians. They both have distinct roles there. So depending on the individual conservation district and what their needs were, looking at their goals towards not only the WIP but other things too, making sure that they had appropriate folks in there. And just by simply hiring a technician or a planner doesn't mean that implementation is going to jump dramatically as soon as they're hired. Obviously, there's an entire onboarding process, getting folks trained and certified to be able to do certain things. So there's going to be a bit of a lag time there. There's no doubt about it. And as I mentioned before, with some of the legislative initiatives, I think there's obviously a desire to for the state as a whole to achieve those goals. So some of my colleagues over at MDE have suggested that MDA is doing a full court press, and that's essentially what we're trying to do is really leave no stone unturned to really see what it's going to take to help us meet our goals overall, not only on the shore but throughout the state.
Thanks. Okay, Kevin, I'll turn it back over to you.
Nancy, thank you. And thank you to all of our WIP and conservation participants. We really appreciate you guys taking the time to be with us. So right now we have a few minutes for questions. I haven't seen any new ones pop up yet, so I'm going to start with my own. I'm going to ask Chris Basin with the Delaware Center for Inland Bays to talk a little bit about how what we've heard today about the Chesapeake Bay relates to the inland bays. Chris?
Thanks, Kevin. In terms of water quality trends and nutrient trends, I think what we've seen today is somewhat similar than what we're experiencing in Delaware's inland bays. We have experienced water quality improvements over the past 2 assessment periods that we've been working on. Those are 5-year assessment periods, and the last one that we've completed finished up in 2016. And we've seen improvements in Little Aswolman Bay, which is one of our smaller systems with a smaller watershed and has shallower superficial aquifers, which has probably contributed to those improvements. And we've seen some improvements in water quality near our ocean inlet. We've just been seeing more flushing there. We are working on our next 5-year trends assessment, and those improvements, it's in draft form now, but those improvements that we've seen in the past don't appear to be continuing, and we still have not seen a reduction in loads of nutrients measured in our streams entering the bays. So I think the improvements that we have been seeing in the past are slowing down, and I just want to echo the needs that we've heard here already today. Is we need a lot more funding to accomplish our mission, and we need more people. And I think it's very encouraging to see the big, bold moves that Maryland is taking for putting people on the ground. And from our experience, you just need people to make the partnerships and get the work done. So really great leadership from Maryland there. And that's a good summary of what's going on in the inland bays.
Chris, thank you for that summary. I do appreciate it. It seems to be a little bit of a theme of this second half, that if anyone knows any billionaires who would like to give away a lot of money, it sounds like organizations and governments here on the Eastern Shore can find a way to spend that. So keep your ears to the ground for that. Let's see, we've got one question coming in. Let me take a look here. Question from multiple participants from Mark Hoffman. given the leakiness of the Eastern Shore soils, someone said the focus should be more in controlling inputs as opposed to effectively taking action after the fact. I believe that was Jeff. Would be interested in some more expert discussion on this. As for example, does the focus of the cover crop make sense within this context?
I can chime in again on that one.
Sure.
I think in our watershed, we're rapidly developing. So our agriculture is being replaced by subdivisions. And so that, I think, takes a little bit of the focus off the nutrient reduction practices such as cover crops and shifts it more over towards natural filter practices that can intercept that older groundwater that is bringing in the legacy nutrients, for the lack of a better term. But always, in my perspective, a dual focus on minimizing the amount of nutrients applied and getting into the water, and then intercepting those from the landscape is important. And for us, it's not just a focus on wetlands on the watershed, but also restoring the assimilative capacity of the estuary with wetland shoreline creation and oyster populations.
This is Jason. I'm going to chime in real quick to at least provide a little bit more perspective from Maryland. So going back to Jeff's presentation when he indicated that there wasn't a silver bullet, it's going to require a combination of practices. And really, if you look at it holistically, it starts with land management and where the appropriate places are to grow row crops, and in marginal areas and other things, is it appropriate to perhaps retire that or use less intensive management practices on that land. But where it is appropriate to grow row crops, I think obviously the first step in that is proper nutrient management. And obviously Lindsay did an excellent job explaining the 4R process as it relates to nutrient management on that land. And then since crops are a bit leaky, they don't absorb, I think Lindsay, you said 70% efficient. So there's a potential to have some leftover nutrients. And that's where, getting those nutrients off the landscape with cover crops and other practices is important. And then appropriate use of riparian buffers and other things too. So it's really a combination of all of that. So I would say that we shouldn't focus on one BMP versus another. It really is a suite of everything that is going to help contribute to overall load reductions, not only to the Bay, but local water quality too.
Yeah, I think Jason did a great job kind of explaining all of that, but I did want to make one point. We're looking at a whole system here, and I like the NRCS ACT acronym, so avoid, control, trap. So we want to avoid the loss of excess nutrients. We want to then control excess nutrients that may be lost and trap them before they enter water bodies. One common misconception that I think people have is that effective nutrient management is only based on rate, and that we need to reduce the overall rate of nutrients that are being applied to the field. Well, with the increase in yields that we're seeing, those yields growing more crops on less land, because we are losing land to development, cannot be controlled with just a rate reduction. We need to look at nutrient use efficiency, right? And so increasing the efficiency of those nutrients that are being applied on the field by applying them in the right rate at the right time from the right source in the right place is really important. And so I think we need to continue to look at it as a whole system and not just focus on avoidance of nutrient application as the silver bullet solution.
Yeah, I agree with Jason and Lindsay, and I'll just add that, I think oftentimes the misconception is that these two things are juxtaposed, right? That having good water quality programs and having highly productive and efficient agricultural systems don't go together. In fact, they're attempting the same goal, right? Both want to minimize loss of those inputs. Our goal is to have every pound of nitrogen you pay to have applied on the landscape taken up by your crops and turned into grain. So we're working toward the same endpoint, not working against each other here. So I just want to make that point.
Thank you. And thank you, Mark, for a great question. And thanks to those who chimed in to answer. Let's see. Alan asks, what is one thing, in all caps, DLLC can do to help state WIP and conservation leads make the most progress towards 2025? James, since you just finished, I'm going to go back to you first with that question.
I'm going to say the one thing is for Virginia's Eastern Shore is help us make sure we know where litter is going. Keep good records, report them in accordance with the new requirements under the Poultry General Permit and end user regs, so that we can then put that data into the models and get credit for our efforts in transport, as well as efforts to make sure we're applying these manure-based nutrients responsibly and efficiently.
James, thank you. It looks like Jennifer's going to hop off, but Jason, did you have anything to add to that from your perspective?
I would say help us be an advocate for conservation. That's the most important thing. We need everyone to understand the importance of strong conservation programs, not only on the Eastern Shore, but again, throughout the entire watershed. So whatever the DLLC can do to help support the collective partnership in promoting effective conservation measures, I think that is probably one of the most important ways that the organization can help.
Jason, thank you. Thank you. We're about at time here. If anyone has any other questions, I'd be happy to throw them in. Feel free to speak up or type it into the chat. I'll give another few seconds here. All right, well, if not, that concludes the webinar for today. I'd like to thank all of our participants again for being here. We greatly appreciate you taking the time to share your knowledge with us. We really do. On behalf of DLLC, thanks everyone for attending and presenting, and have a great weekend.
Bye. Thank you all.